Yeah, that's very good. You like my mic? We have two.
So fancy.
We have one mic, and then we have
Is it like a lapel mic?
yeah, it can clip on. Secret. They're the same mic.
Oh, fancy.
So I need to mute this one.
Well, good stuff. I look forward to this.
Well, I need it. I have anyway. My thought was You're unmuted and good to go.
Unmuted.
Yeah. So mute.
Does it go to the room?
I don't have audio. I only have audio. I figure it's a little overkill. I can add audio to the if we need to. So.
As long as everyone can hear the speakers.
Get out there.
Well, what about during the talks? I'm more worried about during the talks for people to hear the speakers.
I can add audio. I just don't have it right.
Guess we get that during the install party or something.
I am doing the install party.
So recap with the install part. I'll just say you'll have more details at that time.
Yeah. Oh, I need
How are you?
any questions?
Just going off to the CUD list.
Literally, why?
Getting the ground running. From Bob Ross. Oh,
He's been on forever.
really?
Yeah, it's my favorite one.
Is it from?
That was like
last
2020.
Come on, probably internally.
Yeah, that was 2020.
Probably internally, whatever.
All right, welcome everyone. Thank you all for coming. It's great to have you all. This is our fourth year, or I guess third year, fourth conference, our third time being in person. A little bit of a housekeeping thing. For any of you that don't know, the bathrooms are the first hall to the left of the elevators. And then a little bit about us. So we started in 2019. I was heading home from my job, listening to podcasts and listen to a whatever the Go podcast is. Can't remember all of a sudden. Go Time. And they were talking about regional conferences and how great it was, and they were hoping that more people would start doing that. And so I wanted to start one here for the kind of Mountain West area to showcase a lot of the great Go talent that we have here. And as a part of that, we're also part of Forge Utah, which is a little community that's all about helping people become better developers and helping further their knowledge. So I invite you all to join our Forge Slack. You can get to, I believe, at forgeutah.tech. And then a little bit of our plans for the day. We're going to start off with a Go install party. Mariah will have a little bit more info on that at that time. Then we'll have some panels. And then after lunch, we're going to have lightning talks. So I highly encourage anyone that, even if you have something not even related to Go, please go sign up for one. Someone might find it interesting, whatever you might have to say. And then we'll have some more talks. And then at the end of the conference, we're going to have a little after party. We have a bartender coming. There'll be drinks and whatnot served for everyone. Lunch is at noon. So yeah, I guess we'll get started with Mariah.
That's right. Thank you. Thank you. Thank you. Hello, guys. Did I not do? Oh, we think that those are sponsors. You forgot Lightning Talks, didn't you? So, hi. If you already have Go installed, I don't want you to be bored. So, you have an hour to prepare a Lightning Talk. For our Lightning Talk hour, the reason being, Lightning Talks are the best part of every conference. We all know this. A. B. We only had one person sign up ahead of time. For the Lightning. Oh, gosh. Thank you, AJ. I'm so glad you're here.
But we're all here.
Who's making who's making notes for things we need to improve next year? Oh, good. We'll have a lightning talk on what we're doing next year. So, looks like I'm using this mic. That's awesome. Okay, everybody got the lightning talk? If not, you can go to our website, GoWestConf.com, and on the lightning talk thing on the schedule, click it. You don't actually, and you can sign up. There's still time. It does not have to be about Go. You can talk about anything under the sun. You can perform a song, pull out your ukuleles. You know, we'll be good to go with whatever you want. I want to share my screen. The entire screen. Yep. Go install party. I did it. On the website, on our schedule, and you click on Lightning Talks. That is the sign up. Anyone can give a lightning talk. I will talk about them again. If you're sitting here bored, lightning talk, or you can help your neighbor. But so this is the Go install party. Little bit of history about the Go install party. We used to do this every year at the Go meetup, and then COVID happened. And now we don't do it every year at the Go meetup. So I brought it back to Go West. So anybody who raise a hand, who has never used Go? My goodness, you guys are all at the right conference. We got one. That's good. That's why the purpose of this talk, there's been a trend, and the trend is remote development. I don't know if you guys have seen this trend as much as I have, but people are like, let's do remote development and have like remote workspaces and do things on the cloud. Even if it's spin up developer environments where you can interact with something on the cloud, and then your code never has to leave your environment and never has to be downloaded on a developer machine and all this magic stuff. It's all over the podcasts. So that's the theme of today, setting up a remote environment. I do have somewhere Raspberry Pi. It's at my house. It's running. That I will be setting up with Go today as my remote environment. So we'll be emulating, that kind of a thing. And you guys can follow along however you want or write a lightning talk. So today what we'll do, we'll install Go. We'll learn about creating projects with templates. And we'll learn about testing and linting because you can't write projects without a linter and a tester. And we'll go on. So AJ, I'm so glad you're here. What did you do? I literally ran this on my machine.
Oh, it works. It's just Go now because whatever the program that you run is, that should be the canonical name.
I agree. I like that.
So if you run Go, it works because it's named.
Gotcha. So, if you haven't heard of Webby, you're not alone. I wouldn't have heard of it if I didn't know AJ. And he said, why aren't you using Webby to install Go? And then Todd was like, Todd's over there. Todd's like, gave me a command to install Go with Webby. I'm like, oh, people use this? And so I was going to click on the thing. I'll show you. If you go to Webby, it's a nice little tool. You see AJ's face right there. And it's a tool for installing things with one command. So if you're creating a virtual work environment and you're like me and you can never remember how to structure a curl to download a stupid binary, AJ already did it for us. So congrats, AJ. Right? You this is you, right?
That isn't me.
Okay, give AJ a round of applause for putting his face on a website. Go ahead, you got something to say?
Can I take 60 seconds when you I'll take it now. Okay. All right. Just so this is clear. All right. So it's really important that people know that if you go back to that or click on the Go, scroll down a little bit and click on the Go one. Yeah. Okay. So there's two things that are really important to know. Is this fake? Does this
No, there's sound coming out of there.
is there? I don't.
You can't hear it. It's
Oh, it's for the live stream. Okay. Okay. So two things to know about this. Number one is that this installs the official Go package. This isn't a third-party package like what you'd get off of Brew or apt. This is actually straight from the Go website. The way this works is that it curls the Go JSON file that has all the releases, selects the correct one for your operating system, and then uses the tar to unpack it, which is important because it means it doesn't change permissions on /user/local or /opt, which means that it doesn't screw up any other installs like Node or other things that like to change the permissions on that directory. So that's number one. And number two, there's also Go-Essentials, and Go-Essentials will also install all of the tools that you have to use anyway. Like if you were to install Vim Go or a VS Code plugin, you'd end up installing all of the like Go Stringer and I can't remember off the top of my head. The language server, yeah, like all of the stuff that you must have in order to realistically use Go in a development environment. GoEssentials installs that. So the difference between the two is Go just installs Go. It just uses the package installer from Go's official website, or not installer. They package the tarball from the official website. Mac, Linux, and Windows the same. And then Go-Essentials installs the other stuff if you're actually going to do development. Okay, that was more than 60 seconds. I apologize.
I am just really glad you were here for that. So thank you again, AJ. So yeah, we've got this nice little thing. And like I said, I'm going to actually install something today. So I should be able to just, yep, there we go. Now I'm on my Raspberry Pi, guys. And I need, oh wait, that's the wrong way. It's up. Curl this. Or actually, should I get, you updated it to be just Go, or you said, no, this is Linux. My Raspberry Pi is Linux. So.
Yeah, it's okay because when it runs Golang, you'll just see a couple messages output twice because it'll say Golang is
Oh, it's already installed because I did it for test. But it did it again. Actually, here, let me turn the lights down a little bit.
If you want to do it again, you can just delete the directory.
I will. There we go. Now you can see my screen. Where is it? It's in local option. That's where Go is. Okay, let's kill it and do it again. Because it's, yeah.
So what's the benefit, or like, what does this do different than Brew? I'm just familiar with brewing everything when I install.
So
Wait. So the question is, how is this different than Brew? And AJ's going to answer that. There you go, AJ.
So essentially, it's more secure and it's faster. So it's not a third-party build. This is actually, it downloads it from Go's website. You'll see when, well, you won't see it because unless she deletes it from the downloads directory as well, you'll see it downloads the tarball from Go's website. It's not a third-party build. Also, it doesn't require sudo. It doesn't change any of your system directory permissions. And it doesn't require a git update to get the latest version. Whatever is published on Go's official releases.json file is what is immediately available. So if they published it 5 minutes ago and you run the command, you'll get that version. And then you can just switch between versions by just using an @ sign. So if you wanted Go 120 versus 121, although I don't know why you'd ever need to use an old version of Go. But Why use the PKG? Why not use the PKG? Okay, well, I'll say the reason that I recommend not using the PKG is because it will clobber the permissions on user local. So that's the only reason to not use the PKG. Well, and then also your path is set up to a system path rather than to a local path. But that's the main reason is that the PKG, not because of the way the Go authors did it, but because the way that Apple does it, PKGs only install at the system level. And so they always change the permissions on user local, which if you're using Brew, for example, and then you install Go, well, now Brew's permissions were messed up because now Go has reset the permission,
Thank you. My thing, the reason for this again, I have always downloaded it from the Go website. I was told the reason I don't use Homebrew is because I always have had back in the day before Go modules exist, Homebrew would always screw up my Go path. So that's why I've always downloaded it from the Go website, because then it didn't screw up my Go path. Now that's not as relevant. But the really nice thing, and the reason why I wanted to highlight this time, is A, because you can copy it from a website and it's way easier to remember Webby than it is to remember curl commands. And B, because it had a Windows option. And I would not for the life of me know how to install Go on Windows with a single command, right? Doing it with the download is a multi-step process. And this is a single-step process, which is great for a remote developer environment, which is the whole idea of my install party. See? We thought through this. And thank you, AJ, for coming to my conference to explain this.
I'm so excited that you're using it.
So now it's downloading it. See, I ran it. It's downloading it. If you don't have a downloads, because it's a Raspberry Pi, it creates downloads for you. So it's fantastic. And now it's like set up to work. Like I don't have to do a single thing. I just go version, and it's there.
For everybody else, it would output run the source command or restart.
Okay. Yeah. So if you're on a Mac, do what the thing says. This is a Raspberry Pi. I do like to mess around with my Raspberry Pis, and I often get to the point where I'm like developing something locally. I try to deploy it, and then I'm like, crap, it's broken, and then I want to fix it where I have it running, and so that's why I like to have this set up. Cool. Where was this? So that was step 1, really easy. If you have any questions, like he literally tells you how to create your own Go thing. So I think everybody that should go star this on GitHub. That is, if you're not writing a lightning talk, go give it a star on GitHub. That is your assignment. You're really close to 1,000. So next thing, oh yeah, this was my check. I checked that it was installed. Recently, I don't know if you're like me. I have, for everything I create that's my own, I have a template repo on GitHub that I clone, and it has like an init. It has my linter in it. It has a Docker file ready to go. It has a Go file ready to go. It has just my basic everything ready to go. This is new. As you can see, it's in Golang X, which is experimental. The Go team is experimenting with a single command to create new projects on the command line. So you could run this. This is how you download it, which I will do in a second. Now that I have Go installed, I can do that. And then you would be able to create a new repo from basically whatever template that you have set up as a module. So it's pretty cool. So you could do your own custom template. Their examples are using theirs. I didn't actually get this set up because I was planning a conference. So sorry, guys. We'll just do the demo one. So I can install this. Like I said, we'll just do the demo template server that they have. So you do Go install. And Go install, once you have Go set up, all modules can be installed with Go install. So anything that's built in Go, you can use that to install. It's pretty nice. And then let me go find this command on the internet. It was Go package. What is it set up? repo. Well, I just let me go new. It's called go new. No, not go Mew. This isn't a Pokemon. There it is. So this is their example that you can't see. I'll put it on the server. So this is a module they have set up, right? So that hello server is their module that you can install. Like I said, I can create my own module, and as long as it's deployed as a, like set up as a module through the LSP, then I can download it and use it whatever I want. So I could use my template repo without having to go through Git first, which sometimes is nice. You use the go new command because we installed it, and that will set up a new template server for you. And then it runs the go mod as well, which is the step I always forget when I set up a new repo. I'll like start a repo, download my Git template, build the whole thing, and then try to like import something. And then it'll be like, where's your go mod? And I'll be like, oops. So this does that for you. CD. Should be able to CD to my server, right? And now we have a go mod, a server.go. I don't know what that license is, but it's nice. So I think if you were going to do a remote environment, that would be really nice to set up and not just, single command, have everything set up. That was my intent. I just didn't finish the demo because, I was busy. The next thing, is to set up testing. So this package right here, go test, is a wrapper for the go space test command, and it outputs your test results color coded. So if your tests fail, they're red, and if your tests pass, they're green. Do I have broken tests somewhere? Oh, I do. Let me show you. It's pretty cool. I think I have broken tests somewhere. No. Where is it? Code. Go projects. So you just run it like that, go test, and it wraps the regular go test. So you can just literally do go git and install this, and it's, see, green, because it passed. And then if it fails, it's red. I recommend everybody get this because it makes writing tests fun instead of horrible. When I do my courses with O'Reilly, I did this last time. I did a course last month that was October 3rd, and I said, okay, we're going to write a server, and then we're going to spend an hour writing tests for our server. And people, like, when we got to that section, just deliberately logged off. They're like, we're not doing tests. And I'm like, too bad, because the test they wrote the first day, they had to use the second day. So they had to write them again eventually. Cool. No, I ran that go test. Look at that. The last thing that everybody should have when they run anything anywhere. So if you're doing remote development, I highly recommend having a linter because it's going to save your behind every time. GoVet keeps improving and it keeps catching things. They gave a talk about this at GopherCon about how GoVet added 3 more things to check. And I'm like, oh, GoVet? So GoLang CI lint is my linter of choice because it has a GitHub action that you install and it runs for you. It's just like one button and then it like lints every time you push. But every once in a while, I like to run it locally. The reason is you can add a file to your repo that says this is what I want to check for. And so from my template repo, I can have that YAML file in there. And then everything I build has the same linting requirements. I don't have to rethink up how to do this. So, that's how it works. We're going fast. Where's Derek? It's been a half an hour. So you better think of questions for me. Let's download this. Will this break? Where is my Raspberry Pi? So it'll curl the binary and it's installed. So now I should be able to just run GoLang CI lint. Oh, and the version. And so now I have that version on there. I wonder what version I have locally. 150. Oh yeah, I do have the newest one. So you can just run this. Go lang ci lint. Run. This one does, and it will lint everything for you and say, good job. Oh, nope. Look at that. Look at all of these unused functions. Can you see that? The return error is not checked. Return error is not checked. Somebody's writing bad Go by not checking their errors. Unused variable name. Unused variable name. Lots of I'm taking up bits of memory in my Go stack from the unused variable names. You want me to do what? You need audio? Okay, give me a minute. This makes it hard for me. Okay. Stop presenting. Hang out. Yes, audio. Now do we have audio? Oh, I muted it. Okay. Let me see if I unmute it, if it fixes this. Now do we? Is that better? There's a little bit of a delay because I'm going through this computer to come back to this computer. Kill it? I can yell. Twice as good? Okay, if you can't hear me, just let me know. And my natural tone is this loud. And if this is not good enough, I have like 10 more decibels before I start yelling. So, how would that, what else did that link? This is like literally the end of my Go install. So now, should we install one of my GitHub projects and see if I can run it on this Raspberry Pi? Is that what we should do next? And oh, AJ, did you have a comment? Okay, I thought you were raising your hand. Are we good with that? Everybody good with that? How are the lightning talks coming? Okay, perfect. I'm glad the lightning talks are going fantastic. Okay. GitHub. Repositories. Which one has something that's actually fun to run? Let's do this one. Okay, so we can go back here. This is the Raspberry Pi. Git clone. Actually, I had to, Git was not set up on my Raspberry Pi, so I had to do that before this, so. Yes. I thought we did this before. What? Oh, I can't do that. Public key issues. Boo. That means I don't want to do a private key. Gotta love GitHub, right? I can do it on my other server. I do root. That's still me. Mm-hmm. Okay. Haha. So this one, I did not set up the fun way with Webby. I set up the hard way by trying to why doesn't it autocomplete? There it goes. So I should be able to go up here. Go run. So these are fun because it's like a whole bunch of nested things. What do I have in here? Let's run some tests. So I can do go test. Yeah, the rest will go EX-4. dot. I think I want to do it verbose. No, go test is not installed here. Go command. See, go is not even installed on this one. Time to go back. Look at me doing it all over again. Copy. I thought I had Go installed. I guess I run everything with Docker. Look, I set up 2 remote environments today, guys. Aren't you enjoying this? This is literally what my Twitch live streams are like. You just sit there and watch me do stuff and make bad jokes. So that is a call to action that if you enjoy this, you should follow me on Twitch. Yeah, we turn the audio on and it repeats. So it's like I talk and then 3 seconds later I talk again. Oh, I don't want to use Weave Save though, Paul. Thanks, Paul. Now can I do that? Go command. Didn't we install this? If I do go version. Go command. Do I need to source that thing that you said?
Yeah, you just need to source it or exit re-enter the shell.
Source what?
Just hit Control D and hit up.
Control D. Oh, look, I already. Thank you.
It's easier to copy and paste it.
Oh, it works now. Go test. Restful. What? Did I spell that wrong? Oh, I have to CD into it. Duh. Miscode, web services, RESTful Go. Okay. Go test. Go test. RESTful Go EX-4-test -v. What? Do I need to do a go mod init now? See, this is why I don't like doing new things live. Cool. Well, I think that is. Oh, look, this was the YAML for setting things up. This it clearly cuts itself off, but this is what this is setting up a deploy for your thing, so you can do remote deploys right to GitHub and share it with everybody. And that was all. I have a half an hour left to kill, guys. Oh, I know what to do. I remember now. When I had time to kill, we have a ton of shirts from last year. Only like 62 shirts from last year. It did not these shirts. It's that shirt, the Viking gopher. So we're going to give shirts to everybody who could answer my trivia questions. And if you don't want to do that, you better write a lightning talk. We'll do that. We got 20 minutes to kill. So, but I do not have any like Go trivia ready to go. So if anybody else has a question, you'll get a shirt. No. But you have a question for Go? Oh, no, I don't. It was not. I am horrible with puns, so. Cool. I got one. What version was mutex profiling added to pprof? There's only been, it's after V1, and there's only 21 versions. So you just start guessing and you'll get a shirt. No, you have to only guess one version at a time. What version was mutex added to? No, not 17. Did you have a guess? Yeah, you raised your hand. Okay, what Go version was mutex profiling added to pprof? No, but close, Paul. 1.6 is close. No, no. Then you don't get a shirt. It is 8, Boston. You can go get a shirt now. You can have a shirt. We'll cut it in half for you right there. I brought scissors.
For the install party thing, do you happen to have a link to all the commands you use?
Oh yeah, my slides are. All the slides I have are on my GitHub repo talks. Did I publish that yet? No. But I will push up a PR after this. But I have a GitHub repo talks that's there. Also, this install party is officially sponsored by my company, Soy Pete Tech, just so you know. So is also clearly this giveaway of t-shirts sponsored by my company. My company, does it do anything? Yeah, but I don't know what it does. Okay, now I have to have it. It does do it in Go. Gosh. Go docs. I don't want to read Go user manual. These are Go user manual? Cool. Okay, I got an easy one. I don't remember the answer. Oh, I do remember the answer. What Go version was modules added? Brandon got it, was 11. Derek, are you giving away the shirts? Okay, go get Derek and he'll give you a shirt. They're all white except for the 3 black ones. What's another? Anybody else have a trivia question for Go? Because I did not come prepared. Okay, AJ, you get a shirt for that. So if you want another shirt.
I might.
Okay.
All right. So when Go was originally announced, one of its key benefits was how Go routines were going to have 0 downtime garbage collection on multiple threads. In what version of Go was this actually implemented?
Again, you can go 1 to 121. Start guessing. Somebody will be right.
1.3. 110.
Nope. Nope. That would have been a good trick question.
1.4.
You can use, all right, now you can use Google. I believe that it was 1.5, but somebody who's Googling is going to double check me on that. It was either 1.5 or 1.6, if I recall correctly. I think that it was after Caddy hit 1.0 or the same year. So I'm gonna go with 1. Who said 1.5?
Okay, go get shirts. Both of you can have shirts.
Although they were just guessing, so I don't know that it.
I don't care. These shirts have been sitting in my spare room for a year, so get rid of them. Did you have a question? Sorry, it was Go 1.5? We checked it. Okay, go ahead.
How do I update from one Go version to another?
How do you update from one Go version to another? You just install Go again. So the Webby command, install it again. It'll update for you automatically.
You can also use Webby Go at 1.
Oh yeah, and you can specify the version. Webby Go at latest, Webby Go, it just automatically does latest.
Even without that, the standard instructions on the Go website, basically, remove
Do you have some questions, Eric?
Separate.
Oh.
Also, I forgot to mention, we are doing a raffle at the end.
Oh yeah.
We have some awesome prizes. We're giving away it's called Pocket.
Yeah, an analog pocket.
Pocket. It's a Game Boy Advance.
With the game that our speaker Brandon built in Go.
It's actually flashed onto a cartridge.
You don't have to purchase it. It's open source on its GitHub. Okay. Selling it. Brandon, there's your business. Oh, you want to do that now? Okay, now since we're killing time, Derek says if anybody is hiring, did you have something, Paul? Okay, if anybody's hiring and would like to share that they're hiring or introduce their company, we are going to give you a minute to talk about how your company hopefully uses Go. You can just say it because unless you want it on the live stream.
I mean, I'm going to give a lightning talk on this too.
Okay, cool. Lightning talk on why you're hiring is fantastic. Okay. No, do it. Do it now. Do it twice.
Yeah, we use Go in our back end. We build precision advertising. Oh, sorry. Yeah, me. No, we're called Agility Digital. So we're looking for an experienced Go engineer. I'll talk more about what we do during the lightning talk. We get hanging on $500 million industry. We get stuff, which we're getting stuff.
Oh, I said I did.
Just for context, we have two back engineers. So
That doesn't need to get lost. Also, Spot, if you want to join the Forge Slack, which is forgeutah.com. No, forgeutah.tech. Don't go to .com. Forgeutah.tech. There is a jobs channel, #jobs. It is the most active and accurate job board in the state of Utah because LinkedIn sucks. So, Julie, you have a job or a, okay.
So my company is called Splice. We're in the coolest product space, which is music production. The company's based in New York, but our engineering team's all remote. We're hiring a senior engineering manager and a senior front-end engineer. Good people only. Like be good at your job. I want to work with you. Yeah, I guess. It's actually a really cool company. So yeah, hit me up if you have questions.
Cool. Anybody else? Okay, now I have to. Okay, I have one. Is anybody familiar with the XP bar package? Because if you're not, you should be. It's the best way to log. It's metrics. It allows you to log metrics to an app, and natively to your Go servers. XP bar. Oh, now you're Googling it. I was going to ask how many types are built into the XP bar library? Because that's what I have up, so I can count them. Guess the number. It's less than 10. Really close. It's 7. Everybody who said 7 can get a shirt. Yeah. They're in that box, labeled by size. So XP bar, what it is, I like it. It's just a native metrics collecting tool. It's so you would basically import it with an underscore, and then you would just do publish, whatever type, set up a variable for it, and you can add counters to it. You can add static variables. So if you want something like last file published or last message published, throw an ID up there. You can count successes and failures. Really lightweight. They export right into Prometheus. I do this in my O'Reilly course. That's what my company does. I create content for O'Reilly and teach them in live courses. So we use XP bar all the time because it's really easy and it's just a web page you can pull up and look at and be like, oh, beautiful. Cool. Awesome. How about we take a 10-minute break? Well, it'd be 15-minute break, and we can get Brandon set up and ready to go. Go get some food and come back for, well, Brandon, you're not next. The panel's next. Sorry. So we'll get the panel set up and ready to go, and we'll come back here in 15 minutes. That sound good? You got 15 minutes for a break.
This is I got a whole behind conversation started. I don't know all this stuff. When I first got the cartridge, that's like that's the part that shows originally was just like the game itself, like just way new. It pulled up together, but the fact that it was created as I started adding there's on a cartridge. It's a piece of footage. Just told my name. Of course. Since it's like a lot more. Like how it already works. Go back. Okay. I think it was a fun little project. So already started. I'm not gonna talk about it. See you guys. West Valley. No, I mean, this is hospital, so I think it's so. That was actually the talk that got me going. That was my first talk. Oh, was it? It was like I said that advocated, but it doesn't talk. I saw the sure a lot of that. Yeah, you got at least one person. There we go. We're go pretty far away. What makes that I did all known by first place. Second place was like engineers, you know, building as well as all that. Monolithic mic services. Nice. So right now, oh, okay. Well, you know, actually, it's it's really like but that said, like this is super I think it all balances out. Like there's a shortage of people, so a lot of there are a bunch of things. The other was the only thing is like I think there's 4-hour flight down my laptop. That sounds like it's shows go like that's why I don't know. And of course the editors do things like actually, yeah. Pushing you. Like you look forward to something that you both see on this like I don't ever use the I don't know. I seem like bigger rides. I don't know what that would be their it's hard not to. Imagine if you have a Fidelity account and you like kind of hack. Like here's the price. So I bet you are. Super youngest son. So many years. He's got to see the oh my gosh. I didn't know he's still there. So that's good thing. That's something yes. 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 Not bad things came at once. And then we started filtering them all out. Yeah, like it's yeah, it's nice. What's your role? So I'm
Dude, the next like branch that
yeah. They so much fun. Actually a real team. Like
for so long.
I felt so bad for him.
It's like
Yeah, now we have like three engineers, a front end engineer, project manager. DeFi's on our team for the phone. She plants all our that's a lot of emergency mode until that's he's got just crazy. That's my most things for yeah. I got like plant, but like the use plants, you know, like there's always things that pop up. Yeah, it's like so it's surprised when air and they kind of go in
Another one.
I'm saying that there are
very good solution. Yeah. Like the designers in there. We have like the design manager and like the engineering team. Everyone together. It's not that one. He went to school. It's okay for school. University questions and that web development. Front end thing. I was like, I don't think I hear more years, but it's okay. I made it. It's that part of oh, that's only one boss. I like and then it's about I'm going to meet up and like, you want to write something? Most of it.
I just showed up.
And so like that's where it's hard to train girl. It's like I don't know how to put this video.
Actually, rather than I think it would be more fun.
I'll learn it.
I think we got everybody. So, all right. Good to be with you all. Go West. Interfacers and some others that are not. So welcome. Since your first time. Name is Paul McKay. Work at Weave. Blah 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 blah. But I'm here to facilitate this panel discussion of these experts in their field. Not out there, but Derek is the CEO of Basel, wonderful company. Casey, data expert in for blah blah. Yeah. At Weave. In Boston. Is that right? I've met you before, but now I know your name. Tell us a little bit about yourself.
Yeah, so I'm a software engineer down in St. George at Bayesian company. We work on print management and workflow automation. So what I work on specifically is business critical printing, hospitals, shipping plants, 100% uptime.
100% uptime. Okay. So we're going to find out if that's really true when it comes to databases. All right. So the forum or the kind of the outline of this process, we haven't had any panel discussions so far this morning, right? Nothing. Okay. So what we're going to do, a little introduction, which we've done. We have some pre-canned questions that I may use. And then we'll have some questions that you might have. See if you can stump them. Okay. So first of all, if I were to choose a database, well, let me first of all, why would anyone choose a database? I choose a database. Files are fine.
Yeah, if your Google Sheets gets too big, then you go to a database. Right?
Everyone's got that. Write that down. Google Sheets too big. Go to database. Okay, first one. Okay.
Yeah, Slack is a great database. Just put all your
All
information.
right, go on for the next one.
Also a secret manager.
Yeah, I won't go there.
Yeah, as much complexity as you can push out onto the database, it lets you solve concurrency problems, lets you deal with all kinds of hard issues that have been solved at scale by the biggest companies of the world with millions of person hours going into the database.
Okay, so there's going to be databases sometimes. You've established that. There's only like 2 databases to choose from. Wink, wink. How do you choose a database? What are some of the principles you say? Okay, I know I need a database, but which one do I choose from? Because we have our varieties. Every one of them says they're the best for every scenario or not. How do you choose? What are the principles that you use to choose a particular database?
You're right. There's only 2 choices, Postgres or MySQL. Any other choice is wrong, especially early on.
Oracle Rack is the only choice, I thought.
How much are they paying you to do that? Say that?
Nothing. But...
Right? They're both. One that says MySQL is terrible is someone who had problems 20 years ago and none of their experience is relevant to today's MySQL. Postgres and MySQL are more similar today than different. Pick whichever one you have the most experience operating and you'll be happy.
Okay, wonderful. Casey?
Yeah, I am a huge proponent of standardization. I think building tools around the tools you use is really important for any company. And so do what your company does. And then you can have the expertise of your other developers that work there help you get up to speed on that particular database. If we're just staying with relational databases, then yeah, there's 2 options. But
oh, wait, okay. He just asked, well, excuse me, I'm going to ask the question. what's rational about a relational database versus a NoSQL database versus the hybrid that seems to be kind of in between? Why would I choose one over the other? Smooth.
I'll give my thoughts on this. Relational is really good when your data is structured, you know what it's going to look like, and you're pretty confident in how it's going to be. But NoSQL really comes into play when you need things like text search. It's very free form. You're going to let any kind of data come in and out. So that's what I'll say.
Okay, this is a question for the audience. No trick question here. How many are using solely a SQL database, a relational database? Hands up. Only. Kind of like this. I mean, okay. How many are using just a NoSQL database? And how many are using both? Okay. Thank you. All right. I didn't quite understand then how to choose if they all use both.
This is my hot take. There's no reason to ever use a NoSQL database.
Sitting. There you go.
Postgres and MySQL are just as fast at key value lookups. You can store JSON blobs in them just the same as you can with a key value. There's no reason. If you do have like larger blobs, there's S3, there's GCS, there's object stores that you can put that out and store reference in your database. But unless there are very rare circumstances where an actual NoSQL database is worth the extra effort to stand up, to add it to your operational overhead, because you're still going to have a Postgres or MySQL. Most of the time you can do good enough full text search. There's obviously specific databases for things. You can do PG Vector, PlanetScale just announced vector databases in MySQL. You can do most graph relational stuff in a relational database. Unless you really, really, really have high scale and have actually fleshed out all of the options available to you in your core database, don't look elsewhere. Don't cache elsewhere. Don't do anything elsewhere.
All right, let's get, no, just a minute. Just a minute, because I know you want to hear the opposite. Why? Or are you gonna support Derek?
I will add on.
Oh, okay.
And there's, I have had really good success with the SQL databases like Firestore. There's smaller reasons to use some of these NoSQL databases, but I do agree that it's the 80-20, right? So there's 80% of use cases, and most of those are satisfied by a Postgres or MySQL, and you should start there. Currently, we're running into issues with search in Postgres. There are extensions you can add to help with that. But we're getting to the point where we're into the use case where maybe we need something that's tailor-made for search. We're looking elsewhere for that right now. But we started in Postgres and we just lost search there already. So I'm kind of the opinion that you should start in a relational, and then if you get to the point where you're kind of breaking at the seams, you can find a tailor-made solution for that thing.
Anything to add before we go to the audiences? Good. All right.
I was going to ask, is overhead your main argument against it, or what else?
Okay. Overhead meaning?
Because you were saying, hey, don't use a NoSQL database because, it's one more thing to set up. It's one more thing to maintain. Besides that, is there another reason you would say never use one?
That's basically it. Just operational overhead. Then you have to sync between databases. A lot of them are by default eventual consistent, which now you've pushed a ton of complexity back out on your app devs. And again, except for some specific use cases for full text search, they don't generally offer enough advantages over your core database to make it worth the extra infra complexity.
Okay, so now we had okay, Frank, I know you have an opinion on here.
Of course I have an opinion on this. Yeah, so I was just gonna say, it seems like, Derek, your first stance on why would you use a database, part of that was that it reduces the complexity of what you have to code. Oftentimes in NoSQL solutions, they don't reduce the complexity anywhere near the level that using a relational database will reduce the complexity for you. And so it makes sense that you would want to use a relational database basically whenever you can. But there are going to be cases where different scaling mechanisms, where different availability mechanisms might be significantly better on a NoSQL or a non-ACID with using potential consistency. It works out fine if you go through and put in all of the extra work, which is a lot of extra overhead.
Okay. So, big data and relational databases. No problem.
I would say
big data is not necessarily a relational database.
Wait. No, that's absolutely correct. They're not. But should you use a relational database for big data?
I'll give the same answer I gave earlier in that use it first, and then when you start breaking at the seams, then you can find a tailored solution.
Okay, Casey, breaking at the seams, trying to do it till, okay, give me the edge cases of when I'm actually gonna make that choice. What are the things that I'm gonna say, just Casey's right. I'm right at that point. I need to make a choice. It's gonna be NoSQL. What are the actual cases?
To me, the first one, so search is one, if that's really core to your application, maybe you go there. But again, having to sync data out, it's just so much extra overhead. And even if you might get some small operational efficiencies because the NoSQL, right tool for the right job, maybe it is perfect. But if you just put the same or even less work in, just adding more CPU, adding more resources to that database, Postgres will handle that just fine. OLAP, analytical databases that are columnar would be generally my first place where I would say, here's a completely different, it's not transactional. I have dashboarding needs and they're not real time in the same way that a transactional database is. That's probably the first time I would step out.
Some examples of those columnars that you'd think about?
ClickHouse, DuckDB, BigQuery. There's some cool new stuff happening with Apache Icebergs. What we're looking at moving stuff that you can store files on GCS or S3 and then expose it, and almost every data warehouse can read it natively. So it's pretty cool for separating your storage and putting it in a cheap spot versus locking yourself into one querying engine.
Casey?
Yeah, I'll just add that your use cases will tell you if you're breaking at the seams in terms of like you said, if you need real time, transactional workloads, and then it starts to get seconds where queries are thinking, or multiple seconds or tens of seconds, then it's like, okay, well, my users are getting angry. And then you can go through like, oh, well, maybe I can optimize this, or change my queries to help make this better. And then if that, you've exhausted those efforts, then it's like, okay, maybe I'm to the billions or even trillions of records, and then maybe I can move those into a columnar store.
Yeah, I think that's a great point. 99% of use cases, you're not going to hit that. And so just going with Postgres or MySQL until then is going to be the most efficient and effective, cost-efficient choice.
So it sounds like you hit a certain size, certain conditions where you may not need one versus the other. Maybe one's better.
I think, I can't remember for sure. It might have been Figma that recently published an article about they thought they had hit that size, and Figma's not a small company running just on Postgres. They thought they had made it there and started looking elsewhere, and then decided, actually, let's just make some changes. And then they dropped their consumption 50% just by some of these smart optimizations. So again, most people and companies will not need to scale beyond just that initial
comment or question.
Yeah, I was gonna say one of the big concerns with NoSQL databases is yeah, not being ACID compliant. But you have NoSQL databases, MongoDB after 4.0 being a prime example of an ACID compliant NoSQL database. So you can have all those perks of transactional databases with NoSQL. And to counter like what's a good use case, in my opinion, for NoSQL is if you're a startup and you're not sure exactly what your product is yet, and you are rapidly changing how your data looks like having a relational database to start might not be the best option because you're going to be constantly doing migrations and such. I like the flexibility of NoSQL, and you have the perks of the ACID compliance with like Mongo or another ACID compliant NoSQL.
So let me just follow up. So what you're advocating is fast moving, quick, flexible, kind of prototype, get it to a certain scale in NoSQL. Would you then think, okay, I've done that. Now go to relational?
I think it depends on the use case. Like depending upon the nature of, you know, industry, if it's rapidly evolving, you're going to be adding a lot of extra fields and stuff like that, and you don't know what the object structure is. I'm not the biggest fan of like storing like JSON strings and stuff like that. So like I like NoSQL for that reason, but like
that smile means maybe there's
something's coming. Something's coming.
Derek.
I mean, Mongo is just a JSON string. It's not any different. And Postgres, MySQL, right? They're storing it as a binary. It's efficient. You can create indexes on it. So it's not that Mongo is necessarily bad. The Post 4.0 is a very important distinction on that.
So pre was bad.
Yeah.
Make sure we knew that one.
It was Snapchat for databases. But you can get most of those qualities with just a JSON column. And usually it's not like I'm slinging around brand new objects. Usually it's, okay, I have a core set of, here's my CRUD objects. They have an ID, but it's the properties on said object that are in flux or quickly evolving. And so it's still without having to do a full migration, though schema is a feature, not a bug, despite what NoSQL wants you to think.
Boston,
yeah, I was just gonna also further his point that I think expertise is a big part of that. So he was talking use case of the product. You don't know what the schema is going to be, but also if your expertise isn't in relational databases at all, it's probably easier to go NoSQL until you either are big enough that you're required to move, or you're big enough to hire someone who has that expertise to make those right decisions.
Frankie, you had your hand up before. Anything?
Mine is more related to a previous topic.
No, it can't go there. No.
Scaling.
Okay.
Talking about when should we scale?
Meaning, when we get to a point of scaling, when do we choose one to use?
A SQL database. What is this? I think this is helpful for people to know. What is the largest table that you have ran with in production that has performed well? Performing well is going to be qualified as less than 4 milliseconds for most queries. What's the largest that you've seen in a relational database?
20 terabytes.
A number of rows.
I don't know, trillions.
So scalable.
So it scales fine. That was on a single MySQL instance. I'm also a maintainer of Vitesse. That's a sharded MySQL option that lets you bypass most of those solutions. You've got GitHub, Slack, Square, lots of big companies running on it. So can scale MySQL or Postgres.
Yeah.
Vitesse makes it the starting bit a lot easier than currently available Postgres options.
So, and then we had another comment here or question. But before we go to that, so what I'm hearing is for most of us, we always think I've got to go to that scalable solution because I'm going to hit it.
Yeah.
And most of us never will in our lifetime, right? So what you're saying is that they can scale up to a 99% of maybe our use cases, again, assuming that we're not a part of a huge Google-ish type, application. So interesting. Okay, you had a question or comment?
Good. I'll just speak loud. So two things. One, there's this false sense of, I don't have to have a schema. You always have to have a schema. You always have to do a migration because your application is going to break as soon as you fetch the data that doesn't fit that new schema, or you're going to have the migration in your application logic where you're just adding all of that. So it's a false claim because you always have to have a schema. It's where do you put the complexity? Do you put it in the database or do you put it in the application? And then I forgot my second copy. There we go.
Recommendation. There you go. In the schema or in the application?
I'm on the schema side because then you have the tooling to handle it for you, right? There's no tooling built to handle custom application logic. There is tooling built to handle schema migration. Oh, and that was my other point was that there's also this false sense that you have to create a column for every single value, which is not true. You only need to create a column for values that you are going to index or search. So everything else can go into a JSON blob in a relational database. And that's probably what you should do while you're starting out so that you don't end up in a case where you're like, oh, all 53 of these columns for properties I may or may not use, I've created. Now I have to do a migration. Now my migration sucks. And you're getting those pain points of thinking, oh, I wish I used NoSQL. No, what you wish you did is that you didn't index every single column when you actually weren't going to use it.
You have a very
Yeah.
all right. We won't vote on the but I think there's a lot of That's good advice there.
Quick note on that. You can, in both Postgres and MySQL, you can add indexes even on nested, repeated JSON. So there's not even a requirement to have a separate column for an index.
All right, one more. Go ahead.
Yeah, I was just going to comment that the sentiment is optimizing for change, which I think you should do regardless. NoSQL or we use Goose at Weave and for migrations in Go, and we have migration folders that are like you open it and it goes down really far, but that's fine. That's what the tooling is meant to help you perform.
Okay. All right, let's move on to another one. We kind of touched it a little bit. Do you have a question?
Oh no, it's not related to relations, ironically. But another question. I'm curious of the most common worst practices you see with database integration or implementation.
No, wait. I just want you to look at the slide. Okay. This is not the worst best.
But what are
unless somebody's going to change that.
Listen, I'm just trying to give my team a hard time, put some bad code out there, get some work on.
So, what are some of the worst best cases of practices?
You touched on it earlier. People often think, oh, this database is slow, and they just don't have an index. So 95% of your problems are going to be fixed by either adding an index or people think something's using, especially if it's like a multiple column index, and they think they're using an index, but they don't have like that first column. And so that index isn't used at all. So almost all of your problems for database performance are going to be solved with indexes.
So start out by indexing everything.
Exactly. You want,
is that the worst one?
You want 1000x the size of your table in indexes.
We will audit any, we'll cut out this in the video. It's not a best practice. But when, let's just follow that. When do you decide that you need an index, and how many of those indexes?
With every optimization, doesn't matter if it's database or elsewhere, when you notice it in your monitoring.
Okay.
If you don't, then it's not a problem. Don't spend your time optimizing.
So data drives, not assumptions. Good practice. Did you have any more on that follow-up or anything like that? Okay. All right, we did kind of talk about it from application versus the schema, blah, blah, blah. But let's just talk about the design of API.
One quick one.
Oh, okay.
The other one, holding transactions open too long. I see an anti-pattern. People come in and they're like, oh, I'm going to do this magical transaction in my Go context. And I'm going to open it when the request comes in, and I'm going to commit it when it comes out. That is the worst thing you could possibly do to a database.
So how long?
Playground.
Want nothing but your transactional code running where possible. Make any external API calls, do whatever you can outside of your transactional context. Otherwise, you'll get a ton of deadlocking and cause performance issues that, again, are your bad practices, not database performance
Okay,
related.
just a quick follow-up.
Feature.
Would you suggest on the whole, maybe not every case, that a transaction should be within the boundaries of a function?
I don't think so. One thing that
I think we're gonna use the.
I'll stop out with a no.
I was gonna add one more thing that I notice as a bad practice is in general, people rely, I feel like, too much on the magic, because there is a lot of really great things that Postgres or MySQL do for you, and there's a lot of tooling around them that do a lot of things for you. And I feel like at times teams or developers, especially early on in their career, just expect it to work and they don't need to know about it. And obviously you could go really deep all the way down to the internals of the database to get to understand a lot of things. You don't need to go that far. But I feel like a lot of times developers will just say, oh, if I don't understand it, I'll send it to a data team that understands it or send it to someone. I would just suggest.
But that's you, Casey.
I know.
Yeah. So it's
If all the developers knew, exactly how to add an index or when to add an index or and all of the query optimizations they can do, then, maybe I wouldn't be needed, and that's fine because they would all know how to do it, which is great. But I would just suggest if you're running into issues, instead of jump ship, go to a new technology or throw it over the wall for someone else, I would just suggest to dig in and say, hey, if I don't know when to create an index, maybe I should learn that.
Yep.
And just go a little bit deeper. And that's one of the biggest problems I've seen.
Good advice. Boston, do you have some?
Yeah, I'll
Adam?
just follow with my hot take. Might be hotter than theirs. We'll see. I don't like ORMs. Don't use an ORM.
I was going to go there next.
So, and this kind of furthers what Casey was saying. Instead of just tossing it over to your ORM, understand what it's doing. And maybe you even do it yourself so you can get that optimization.
Question.
Yes.
You kind of touched on the thing that I've been wondering about. My team is tired of me saying, but what about the data model? Because I feel like there isn't enough expertise on a lot of development teams thinking about data and the databases, data modeling and databases, right? So how do we all get smarter at that? I feel like, a lot of us work on our Go skills, right? But we don't throw the same amount of work at data stuff, data thinking.
Nobody uses data, but that's okay.
But we all have to use it, right? And part of what's so frustrating about relational databases sometimes is you feel like you're stuck with somebody's bad decision for years, right? So frustrating. Yeah, what do we do?
So the comment is, we train on other technologies. Data is really, you look at what we do. I don't know about, I'm making an assumption, but I don't think there's anyone here that doesn't use data. Right? But we don't focus or fine tune or get better at data.
Don't have a person on the team who's specifically thinking, how are we going to model all of the entities that we are coming up with? Or,
I think that's the most important part for any database, right? It doesn't matter what the technology is. Data modeling is the most important. It'll, like you said, it causes problems so the more time you can spend up front deciding how am I going to store this, how I'm going to query it is going to pay off for team members that might be complaining. I think I would say just for their own career, there's nothing that has stood the test of time like SQL. It's, we're going to come up on a century here of it, pretty quickly. And it doesn't matter what language they use. It doesn't matter what they're doing. Nothing has shown any sign that it's going to make SQL irrelevant. Even, new SQL or NoSQL databases, they're trying to build compatibility layers because it just works. It's not perfect. It has its warts. You can't have trailing commas most of the time, right? It's annoying. It's hard to compose, but it's what's there. And so investing time and getting better at it is just going to pay dividends through the rest of your career.
Okay.
I wanted to make one point out to that as well. It's just as bad as having no engineers who know databases as having only one or two and having that silo. And so I think that's also super important is if you're on a team where only one of your engineers is your data expert, when did they get to go on vacation? When do you get to plan a sick day and everything? So that's, I think, another key aspect is skilling up all our engineers to know at least a little bit, indexing well, and then just basics of this is good data, this is bad data, and how do we integrate that?
Kind of interesting. We're talking about these technical things, but Zach's bringing up probably a really big one. is that there's some organizational acumen and just how you do things to make sure that things work.
Yeah.
And continue that continuity. All right, we have to finish up. Oh, go ahead.
I'll just say last bad practice that's relevant to that. I hate the repo pattern. Or when people try to abstract their databases away, like, well, what if I'm going to switch from MySQL to Mongo or something else? That's not going to happen. And
Oh,
when you,
wait. Let's ask, because that was gonna be my question. Everyone loves to have these abstractions because you know where you're gonna switch next week to another database. How many have had that 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 ever actually saved the day having those abstractions? 1, 2, Dave, come on.
Pretty good. I mean, I used it, but we ended up switching back to the original.
This person right here.
it means you're doing the lowest common denominator. You don't get to use anything special about the database you are using. You're going to have performance issues because, oh, it's just my magical little repo and it does a thing. And I feel like the primary reason it existed in the past was it made testing easier. But today it's easy enough to spin up a Docker container with an actual database. Just do that. You don't need a repo pattern. It's fine to pass a transaction and not have it be this magical repo. So,
all right,
no abstraction.
Did
Clean
we
another
learn-
database.
did we learn some stuff? Everybody?
What?
AJ?
I just want to point out, if you want a detailed list of his arguments to share with someone else, a coworker, a manager, there in the Node community, there was an article came out called "Stop Using Connects.js." It was about a thing called Slonik. So if you remember Connects.js, and Slonik is like Russian for elephant, Postgres. But it goes. Have you read that article? It's line by line. It's like, you're not actually going to switch the database. This is not actually going to happen. You still have to know the SQL. You're still going to have to decode the errors. You still need type safety. And it just goes line by line and just breaks down all the myths.
If you're in Forge, could you put that link for the rest of us that?
I'll put it in Discord, Forge.
That'd be wonderful. Perfect. All right, we have to finish up. Let's give a round of applause to Eric.
All right, let's also give a round of applause to Paul. Thank you, Paul. Panel. We're super excited for this next talk. It's by Brandon Atkinson. He's going to be talking about building Game Boy Advanced games in Go. So really fun talk. Also pay attention because we are going to be raffling his game in our raffle this afternoon. So give it over to Brandon. Wait. I have the mic. Not yet.
So I'm going to slack you a link here, Brendan. Join that.
I say that again, right?
I'm slacking you a link. I'll fix the thing over. Join that link.
That's close. Should I mute myself or leave it on dialing?
Mute yourself.
There you go.
Use the room mic. And then to just click on is share your screen. Now I have to fix it.
Alrighty. Am I up? Am I good?
Yeah, you are.
Sweet. All right. So let's stop talking about practical things and have some fun. I am Brandon Atkinson. Wait, this is.
Sorry.
You can kind of see my slides in there. Okay, yeah, I'm Brandon Atkinson. I'm a platform developer here at Weave, where we primarily use the Go programming language and build internal tooling and a platform for our developers. We're going to do something way less practical with Go today.
and hack it a little bit to build a working game for the Game Boy Advance. Let's talk about the Game Boy Advance really quick. Many of you will probably remember this console from growing up. It was a fairly popular console. Nintendo sold, I think, like 80 million units, and was the successor to the Game Boy Color, which were successful consoles in their own right. And it was a very nostalgic console for me. Lots of fun games on it, and I'm sure a lot of you remember it fondly as well. If we peek inside, you can see that it's a fairly simple console, mainly just one circuit board and then a bunch of components soldered onto it. You have some external memory, CPU, speaker, link port, pads for all the buttons. And the important thing I want you to notice is the CPU is a 32-bit CPU. It will actually accept a 32-bit instruction set, which is kind of cool. A lot of people think about the GBA as like a handheld 16-bit console, but it can run 32-bit code, which is an important part of what we're going to be doing today. So GBA is our target. So how are we going to get there? Let's look at some of the documentation and tools you're going to need to make this work. TinyGo is a really cool project. It is an alternative compiler for the Go programming language. And the way that it works is it takes all of the goodness of the regular Go compiler to construct its front end. So I don't know if you know this, but the Go compiler is self-hosted, which means it's written in itself. And you can find all of the packages they use for like parsing and lexing and the abstract syntax tree on the Go package website. Which means that you can build a compiler front end that basically reuses all the Go stuff. And then the TinyGo team does this really smart thing where they link all of the Go front end compiler stuff to LLVM, which is another really cool project. LLVM, for the purposes of this talk, we can just talk about it as a really versatile compiler backend. So you can translate your intermediate representation that comes out of the Go front end into something that LLVM understands, and then you get all sorts of optimizations, all sorts of compile targets, a bunch of really great stuff, including the ability to compile for embedded systems like the Arduino or the GBA in this. So that's really cool, right? That's great that we have the ability to compile for the GBA, but how do we write code that will actually do something, right? How do you write to the screen or get input? So the first thing you're going to do if you want to do this is probably what I did. You're going to go out on the internet and say, how do I write a GBA game in Go? And you're just not going to find a lot of stuff. There's not really a whole lot of documentation available because like this console came out in 2000, or I think 2001. It's not something that people are really commonly doing. And the instructions there are going to be pretty sparse. Instead, what you're going to need to do is take a little bit of a trip into the past and go look at the early 2000s internet. It's a fascinating place. And there are some really great resources on how to program games for the GBA. The homebrew community was pretty big at that point in time. And so you can kind of get a peek into what was happening then and how to translate it forward. You'll need some basic comfortability with C. You'll need to understand kind of how it works as a language. Go is pretty close to C in a lot of ways, and so it shouldn't be too difficult. And I imagine that looking some stuff up online or maybe even using ChatGPT would help you. I didn't have that available to me when I was doing this, but you could use that. The two resources that I would highly recommend are Tonk and GBA Tech. Tonk is more practical. It's going to walk you through how the GBA works with real examples. It'll give you code snippets. He has a very like personal writing style where you can actually understand what you should be doing as the developer to get things to operate on the GBA. And then GBA Tech is a much more dry, like technical manual. There is no operating system. There are no system calls, right? If you want to do stuff on the GBA, you're going to have to talk to hardware map memory. You're going to have to talk to specific memory addresses. And so GBA Tech is a fantastic resource to understand that process and how you're going to interact with the hardware to do things. And then the last resource that we're going to talk about, this is shameless self-promotion. I built a game called Flappy Bird Clone, and it is fully written at Go, almost completely written in Go. We'll talk about that in a little bit. But you can go ahead. It's open source. Check it out. Go read through the source code. As far as I'm aware, it's the most complete example of a game for the Game Boy Advance written in Go. Yeah. So we'll talk about this later, right? Oh,
That was me. I forgot I was sharing.
you're good. So yeah, you can look at this for a reference. If you're like, I don't know how to do this, you can go check out that actual code. And then also you can play it on itch if you're interested in downloading it and getting a copy. So how do we actually, like, let's get into the code. Let's see what this actually is going to look like to talk to hardware map memory. So if we think about hardware map memory, the way that it works is there are specific memory addresses that you have that have special meaning to the hardware that you can talk to configure the display or change how graphics get drawn. How would you do that, right? Like, this is not something that we've had to do since allocators came along, like way, way back. I don't even know when the first allocators were written, right? As soon as we got out of assembly, we stopped having to think about exactly where our memory lives. So this is probably something you've never had to do in your professional career. I certainly have not. How do you get like a UINT16 to exist at a specific memory address? And fortunately, even though Go does not allow you to do pointer arithmetic, it allows you to use the unsafe package to kind of get around that and do what we need to do. So this code snippet is something that you'll see all throughout the Flappy Boot code base. And this is how we interact with the hardware so that we can do things on the GBA. So the first thing you'll notice is this memory map.io address. That is the base memory address of all the IO registers on the GBA. They're packed together in 1 kilobyte. And then you'll notice there's an offset. So I say, hey, this is offset 4. The registers are all 16-bit. And so you say offset of 4, this is the 3rd register in the list of GBA registers. Then you convert from this UINT pointer to an unsafe pointer. And that conversion allows us to cast to a concrete type. So we can say, hey, this UINT pointer is an unsafe pointer, is actually a pointer to a UINT16. So you go through all that song and dance, and now stat is a UINT16 pointer that points to a very specific location in memory so that we can talk to and interact with the hardware. But that's going to cause an issue because Go doesn't want to share its memory. The Go memory model is very explicit about the fact that, like, if the operating system gives me memory, I don't expect anybody else to be able to touch this. So the compiler will rewrite your code and optimize away things that it thinks is not useful. And you can end up in situations like this, where Go says, hey, I'm going to read the status of the display from main memory and stick it in a register because I need to do some processing on it. And it's going to catch that value in a register and start doing some processing. And then the hardware is going to come along and say, oh, hey, the display status has changed. And I'm going to update my hardware register to let you know something changed about the display. Maybe I'm drawing the next scan line or whatever. And Go is not going to get that update because it's cached the value in a register. And it's going to have all of these invalid bits. And you're going to see crazy weird bugs if this starts to show up because you're going to be like, I can see the memory. Why is Go telling me it's something different? The way we get around this is a term that was available in C, a keyword available in C that does not exist in Go, and that's the volatile keyword. Some of you might have worked with volatile memory in the past, but the way the volatile works is it kind of makes the programming language go a little bit hands-off with the memory. It says you can't do funky stuff with this, you can't cache this value, because it might change from underneath you. And so every time I ask you to get that value, you need to reach out to main memory, even though it's slow. Go, like I said, doesn't support this idea, but you can do it with a few lines of C. So you'll see these are 11 lines of C where you can get and set memory using the volatile keyword so that you don't end up in this state where stuff is cached. And you can actually do this directly in TinyGo. TinyGo has a volatile package and it has a registers package that you could maybe use if you wanted to like be really purist about using Go. I had some issues cross-compiling that, and I didn't want to debug them, so I just defaulted to C Go, and that seems to be very portable. So that's what I've been using. That's the only C code in the entire engine right there. And you can see both on the left, the header file, and then on the right, the interrupt so that you can get those calls from Go. The garbage collector is the next thing that we need to talk about. Go has a really fast garbage collector. It's very performant, but unfortunately, the GBA CPU is like 16 megahertz. And even though your entire heap is only 256K, to do a full mark and sweep on 256K on a 16 megahertz CPU, when you need to push a frame every 16.7 milliseconds, you just can't do it. If you let the garbage collector just run like it normally wants to, you are going to drop frames, which for a game like Flappy Boo, that is very uncomfortable because like it's a timing game. It's like a precision game. It's going to suck for your player. And so you have to be a little bit careful about how you let garbage collection happen. Well, there are a couple of different options. So one thing to keep in mind is the way that the default TinyGo garbage collector works, it's actually not the same as the regular Go garbage collector. It's a little bit slower. It's a much simpler mark and sweep implementation. So it is going to run slower. And the default behavior is I'm going to make an allocation until I can't anymore, and then I'm going to do a garbage collection cycle. So if you ask me to allocate memory and I find no space for memory, then I'm going to do a full mark and sweep. And mark and sweep is O of n, where n is the number of objects on your heap, so that can be very slow. So if you run garbage collection more frequently, you can actually pay less of a performance impact. I decided to go a different way and just avoid the garbage collector entirely, because for a small game like mine, it's actually not that hard to just allocate a bunch of stuff to the heap and then just reuse it. So there's this command called print Alex. You can see it in the garbage collector section, where you can actually have the compiler print out like, hey, this is everywhere I had something escape to the heap. And basically just make sure if anything makes it out to the heap, make sure I reuse that resource so that I'm not continually allocating new stuff on it. So like within the first two scenes of my game, all of the memory that I'll ever use has been fully allocated, so the garbage collector never kicks in. That's a great way to avoid those resource solves. So we have some technical details. Let's talk about the GBA itself and how it draws graphics onto the screen. There are several different graphics modes. If you've heard of mode 7 on the SNES, it's a very similar concept. There are modes 0 through 5. A lot of stuff that you'll read online for like Go specific GBA programming, we'll talk about mode 3. Mode 3 is very easy. You basically plot on the screen as if it's a bitmap. And one of the issues you'll find is, again, a 16 megahertz CPU just can't push that many pixels onto a bitmap type display 60 times a second. You're going to get screen tearing and you're going to have issues drawing graphics to the screen fast enough. So we're going to use mode 0. That's probably the one I would recommend for most basic games. It's going to give you 4 backgrounds. It's going to give you regular tiled sprites. It'll give you 32K of VRAM for your sprites. It will give you 256 background colors and 256 foreground colors. We'll talk more about all of this later, but just keep in mind that there are several different ways you can utilize the GBA's hardware. So next we're going to talk about VRAM. There's 96K of VRAM on the GBA, and it is conceptually split up by the hardware like this, only in mode 0. The semantics will change a little bit if you move to a different mode, but you have 4 different character blocks for your background maps and tiles. So a character block is where you store the graphics data. And then each character block can be further subdivided into, I think, 8 screen blocks. A screen block is 2K. And screen blocks are where you stick the tile map, right? So a tile map indexes a tile. The tiles are stored in the character block, and you can use those together to construct a background image. You additionally have 2 character blocks of sprite data. So this is for all of the animated objects in your game. And that is a separate section in memory. You can stick your sprite data there and then reference it in the next segment of memory we're going to talk about, which is OAM. So OAM is object attribute memory. The GBA has support for 128 sprites on screen at a time, and you write the attributes for those sprites into OAM. So things like the X and Y position, the tile index, the priority for the layering effects. OAM is where all of that's controlled. You'll also notice there's this affine sprite data. It's interlaced with the normal sprite data. We'll see how that looks in code later. But if you've ever seen sprites like zoom in or skew on a GBA, like that's how it's pulled off. It's with an affine transformation matrix. Colors are stored backwards and in 15 bits on the GBA, so you get your blue, green, and red channels, 5 bits apiece. The top bit is unused. Sprites, you get 256 colors. It can be a single 256 color palette or 16 color palettes. Same thing for backgrounds, which gives the GBA its limit of 256 colors on screen in mode 0. Sorry, 512. 512 individual colors because you get both backgrounds, both palettes. Okay, so this is how it looks in code. We have, again, same thing where we're taking a UIC pointer, converting it to an unsafe pointer, then casting it to a specific type. The only difference here is we're accessing slices of memory instead of a single value in memory. And so you can use the unsafe slice package to get access to those values. And you can see I haven't heavily leveraged the type system to try and enforce some safety around doing this, because otherwise it's just a giant blob of UN16 arrays, which can be a little confusing. So the next thing is OAM. You can see it was defined earlier, but we redefined it here for some convenience. You can see the different attributes. Each sprite is defined by 3 different attributes. These are UN16 values. And if we look at the attribute struct, there are 3 values in here, but it's gigantic. So this is common throughout my entire code base, Flappy Boot. There's tons and tons of documentation on how all of the features works. I use this kind of as a way to dump all of the things I was learning and understanding. So the doc comment should be very thorough. You should be able to get a good understanding of how to do things. You can see that we pack the things like the X and Y location, the sprite size, priority, tile map, all get packed into these attributes. And then at the very bottom, you can see this unused OAM value, and that's basically for spacing, because again, the affine transformation matrix is interlaced in with the normal data. And so there's actually 2 slices that sit on top of each other in memory, and they use alternating addresses in order to get at that data. It's kind of a weird implementation feature that the hardware uses, but this is how it's supported in my. So let's talk about the PPU, which is the graphics accelerator for the GBA, and how it draws graphics on screen. So to draw backgrounds, the PPU will first go to VRAM into a screen block where it gets tile map data. When it finds a tile index, it will then go into a character block in VRAM where it finds the graphics data. And then when it finds a specific pixel to draw, it will look up the index in the palette data to say, hey, what color do I need to specifically blit to the screen for this background? You get 4 backgrounds. The PPU will do that for all 4 of them. You can layer them together, and you get this final scene with all of it composited together. So these are your backgrounds. The PPU is also used to draw sprites. So you can see, instead of going to first, it goes to object attribute memory, and it will check the X and Y location of the sprite, the scale, horizontal and vertical flip, and the tile ID. From the tile ID, it jumps into VRAM and says, hey, in the sprite character block, where are the graphics? And then when it finds a specific pixel, then it will jump to the palette and say, what color do I need to flip to the screen? So that's the 2 major pieces that the PPU handles, is backgrounds and sprites. And when you compose all of it together, you get your background and your sprite layers all working together. The last thing is input. There's a single register on the GBA that handles, there's actually a couple, but the basic one is a single register that handles input. This might look like a typo, but actually all of the bits are 1 by default. So if a button is unpressed, the bit is set to 1. And as soon as you press the button, it flips to 0. And so you can read the input state of the control pad by simply looking at the bits in that register. And you can see here's the code where we do that. We get the input register, and then we have a bunch of bit masks so that we can read the specific bit to see what button is pressed. Emulation is a really important part. It's going to speed up your development cycle dramatically. And a good emulator can be a great tool to help you debug and move quickly. So I use MGBA. You can put, there are views where you can see what palette colors are loaded, what tiles are loaded into memory, what the backgrounds currently look like. You can look into the actual memory of the console. There's a memory search feature. You can even look at the hardware registers to make sure everything's configured correctly. An invaluable tool. Would highly recommend you have at least some editor. MGVA has been great for me. And publishing. So this is something I think a lot of people kind of forget about when they are deciding to make a game. But really, one of the important things about making a game is like sharing that with other people. So you want to make sure that you have at least some idea of how you're going to get this game out to people when you start making it, because that's a tremendously motivating thing to see other people enjoy your game. So first off, we have GitHub, right? This is the default decision for publishing things as a developer. Just throw it up on GitHub, throw an open source license on it, maybe if you want to share it around. And yeah, this works. If you want to point people to your GitHub repo, they can go download your game, look at the source code, and run it for themselves. The problem is sometimes you want to share a game with somebody who doesn't want to install the Go compiler chain. You want to share the game with your dad or your brother who doesn't understand computers very well. So how do you do that? Well, I use a platform called Itch. You can make a free account. It's very easy to use. And basically it lets you construct a little storefront where you can stick up a download file, stick a couple of GIFs so that people can get an idea of what your game is all about. Would highly recommend. If you want to go play Flappy Boot, you can either get it from my GitHub or from Itch. And if you get all of that done, if you make all of that work together, what you end up with is this. A little game that you can play on an emulator. But here's the problem is like the title of this talk is like, let's make a game for the Game Boy Advance. And like MGVA is not a Game Boy Advance. Like this is a Game Boy Advance, right? Game Boy Advance is an actual physical piece of hardware. Woo! So how do we make that next step to actually get it to play on a real GBA? And the answer is there's a couple of different ones, but the one that I chose was the GBX card read write. It's a flasher. So you can buy from Inside Gadget this little flasher as well as, where I showed it earlier, but like physical flash cartridges that can hold your game. And if you also, the tool that comes with it is Flash GBX. And like if you go through the process of building the game, you can flash it to a cartridge, plug it into an actual piece of hardware, and like turn it on. And there it is. You can actually any questions? Why? Best question, and the answer is why not? Yeah, I mean it's a totally ridiculous thing, but I like the GBA as a target for game development, in part because I think low-level development is really fascinating and interesting. Go is a language that can support that, and also like the constraints of the GBA do a lot of favors to you in the fact that like you just can't go crazy. You can't make an MMO multiplayer shooter on the GBA. Like you get tiles and backgrounds, and those constraints can actually help it be easier to finish a game, right? So I think it's a good platform actually.
Where'd you get your art?
So I made all the art. I am a pixel artist in the evening sometimes. So yeah, I enjoy that in addition to my day job as a developer.
So you've thrown away the garbage collector. You've thrown away some of the memory mapping, or sorry, the memory model. But you mentioned that you still get some of the type safety with how do you describe that? What other benefits do you see in using Go for something like this instead of just C? So that's sort of the underlying thing, anyway.
Yeah, so that's a really good question. Actually, there's a couple of reasons. One is you don't actually have to totally throw out the garbage collector. If you decided to run the garbage collector more frequently, you could probably get away with a small game that still produced a bunch of garbage and you're just, doing a mark and sweep, not on the full heap. I haven't tested that, but I imagine that would totally be doable. You get the type safety. The big thing for me is the tool chain. I don't know if you've ever tried to build a project in C before, but it's kind of a headache. And TinyGo very much follows the Go ethos of just like, you have a compiler and that's basically it. Like that's all you need. Install TinyGo and just build your source code. So like a lot of that complexity being taken out of this process is hugely beneficial.
How long do you think it took you? All the learning and everything.
Yeah, we're coming up on. So I finished this game several months ago. From start to finish, probably took me like 6 months to legitimately go all the way through the process. I would imagine if you wanted to do it from scratch, it would be easier because there are some references now that I've created where you can actually look at how to do something like this in Go. But yeah, it's not a short process. It's not going to be like a Unity tutorial where you could just jump in and make a game. That being said, I've started making another game, and that process is going substantially faster, right? So it's kind of that wall where it's like a lot of onboarding, and then like once you're on, then it actually smooths out. It's the learning curve is high, but then once you're into it, you're. All right, well, I'm going to be around for the rest of the conference. If you have questions, come chat with me. I've had some people ask for physical cartridges. If you're interested in that, hit me up on Slack or like email me. We are giving a cartridge away, so maybe wait until you see if you win today. But thanks for everyone for coming, and let's go have lunch.
All right, thanks, Brandon. Yeah, like he said, it's lunchtime. But before we head out there, I just want to mention a few things. So vegan and vegetarian options are on the black table to the left of the bar where the breakfast was this morning. And then it's also not too late to sign up for Lightning Talks. Lunch will be 1 hour, and then Lightning Talks will be immediately after that. So if you still want to write a talk or a song, if you're feeling brave, go for it.
Johnny, you've been using it.
So much like dense
How much do you value being secured? Thank you. This year,
You suggest
otherwise. The roll on it right now is definitely big. It's like I've been kicking around
better or worse than the pictures this time to check out. I'm not gonna lie, like I on art, and then I was like, I actually should figure out what I'm gonna say.
Not your first presentation of it. Like song.
dealing with
I was like, okay, this makes no sense. This time it was almost a little bit more sense. Great job.
Yeah, thank you. I appreciate it. I'm glad it was a little bit more smooth.
I don't even know how you would like wrap your head around something. Oh, I'm gonna work from home. It's impressive.
Well, thanks. It's a lot of fun. I mean,
they leave it up.
One of those things where it's like it seemed really intimidating. How much of it was
migrating code that already there like maybe that was part of my head. I don't know if you accounting for is like I guess you already had some code examples of what you were doing. So I worked it out, but I'm on the flip side.
My entire first like a month and a half of this was that honk manual has a ton of code snippets, and it was just like, this is how backgrounds work, and like here's the C code to do it. So just copied that C code over and got it running.
And then in the emulator, you just have a background scrolling over the screen.
Yeah. Okay. Yeah. So like a lot of the initial stuff was just like, I don't know how to do this. But code exists in C, so I'm just getting. So yeah, that was a lot of the very first stuff. Once you get, it's like this really steep pedal. Once you get over it, it's like, oh yeah, this is no big deal. Like, Last night, the past couple of days, I've been messing around with emulator, writing an emulator, and I wrote a PPU emulator in like that's the GPU of the GBA. Oh, okay. And so it's like once you kind of wrap your head around how it works, it's not that complicated. It's just like that initial like it's a really dense wall.
Like, why write your own emulator? Now I have Zimmer system. That is, there's plenty of.
This is a really interesting thing. So I want a. One of the reasons I decided to write it to deny you. I want to with my engine. Because it allows me to compile the game with different packages. Right now I have it compiled into a GBA file.
AJ's got two.
But, I'm setting it up so that if I set a compile flag, it will actually switch out and use my emulator.
I got two up.
Take it up on the
Good.
Which you can do by like
some
emulators
the other.
that are written in like
Not a bag of $1,000.
Either I'm going to move somewhere where
you don't have a whole lot of like sites to see what's going on.
Now that I have an M1 studio,
and they have like so it's like
three
emulator. It's that hard for me to write.
I bought this
Write
just
some other
the
video
USB.
that might be interesting to check out.
So I bought that one, but I returned it because it doesn't work with the multiple monitors.
Also, mostly just because you're so
I bought
implementation is like
Amiibo streaming camera.
Yeah, there's
some available in New York City that we've been looking at. I guess we'll take some of those. About a building in
come to lunch.
I didn't know. I don't like dismantling my streaming setup. And I use my mirrorless for this.
That model's gonna leave it. If it blows
I
up.
had the course next week, and so those
I'm so excited.
things I have to do to like set up for that course.
For that reason.
Well, some of them are trying to make office space turning into housing, right? Real estate investment. Real estate investment trust. They're the ones that should invest 70-90% of their profits back in.
They're the only they're what prop up the housing market, the single family housing market. In times when it's cheap to buy.
But sometimes it does blow in their face. But do you remember when Zillow bought all these houses?
You know why? Also, I have your tool in my car. Don't let me forget.
Do you remember when Zillow made an AI model and bought the houses like 20% more and people were like, okay, yeah, maybe, and then they sell it for like 40%.
Yeah, I was cheering that on.
The first time in my
Yeah,
life.
didn't your grandma take for so much money?
Yep.
Okay.
I have to get good.
Maybe I'll pick it up on the.
It's good. No, it's okay. Talk about this.
Then they said, oh, sorry, we're miscalibrated the AI model. Okay, but it's-
Wow.
You should get it on. This is the problem. That's in my house.
We do a lot of open source work. So in the community.
Hey, all right. Welcome back from lunch. We're gonna go ahead and get started with lightning talks. First up, it's a very timely lightning talk. It's from Boston. It's called Spooky Go Link Haunted Code Trivia. So we'll give it up for Boston.
Yeah. So I could introduce myself or anybody who wasn't here earlier. So my name is Boston. I'm a software engineer at Bayesian down in St. George. We do print management and workflow automation. There's cool stuff. We do actually have an associate level role opening up soon. So if someone's interested, come and talk to me. We could chat about it. It'd be really awesome. So this lightning talk is very back. It's going to be kind of silly and very interactive. So like she said, it's Spooky Go. For a couple of years, I've been compiling a list of Go things that when you read the code, you think it's going to do one thing, because Go is typically very simple, and then it does what you don't think it's going to do. And so let's get into it and experience that 5 or 6 examples here to go through for this. So the first one is JSON encoding. So we've all used JSON before. I'm sure. Here we have this main function. We have a anonymous struct that we populate. Has 2 properties in there. It's a time.time and then a string. We get the current time, and then we have start. We create an encoder to standard out and encode it. So what are the thoughts that's going to be printed out from this? Or is it going to panic, or is it going to error, or what? Does anybody have any guesses? Yeah.
It's not going to show anything because your structs aren't public. No, whatever.
A good guess though. It wouldn't show anything because they're not public. Yeah.
Yeah, sorry, that was what I was gonna say. They're not exported, so they won't be in the.
Time is important.
It's embedded, yeah. But it's not gonna, it's all private fields.
Well, when I click run, what's gonna be the output?
Oh.
I think it's a struct with time.
Yeah.
JSON object with just time.
Yeah.
That's my guess.
All right, let's run it.
339.
We got the time. So let's why, right? So here we have, it's an anonymous struct, but time.time is embedded. We didn't give it a property, so it's embedded. And then embedding carries methods, and time.time has a method of Marshall JSON. So when it went through the JSON encoding, it called the Marshall JSON for it and got the result because it's just embedded and not given to a property.
1 second. I think I trusted.
Okay.
Sorry, I wanted to make sure I could see you on your. There you go.
Okay.
You're good.
Thank you.
I apologize.
No worries. Does anybody have questions about this one? Does that make sense? Kind of a silly one. All right, the next one is method expressions. So we have a point struct here that has an x, y, and then we have an add method that returns x plus x and y plus y for the added point value. So this is the easy one. What's gonna come out on this? What do you think will print?
1, 1.
Adding 1, 1 and 2, 2.
1, 1.
Guess is 1, 1. We get 3, 3. So we're adding the 2 and 1 to 2 again, right? Now let's look at the same example. All the code's the same except for this last one, where instead of taking p.add, we're instead doing point right off the type .add with p and q. Is this going to run? If it does, what's it going to print?
That's an That's all it wants.
What's the guess?
There's no point. I think it's going to panic.
0, 0.
Think it's going to panic. Some people are thinking 0, 0. All right, let's run it. It's the same. This is valid Go. So it turns out this is called a method expression. Because this is not a receiver type, you can call it right off of the type on there, and the first value goes in is that receiver. So because it's not a pointer receiver, that's what I meant to say. So that's a fun, tricky one. All right, this is the hardest one, I think. Here we have a slice of ints. We populate it with a single int. called A. We append the A, so now we have two elements, both of them 0. We create a copy of the slice with B, and then we append 1 to A, and so we get 001, and then we append 1 to B, we get 002. If I print the third element of A, what number will it be?
2. I want it to be 2. 2.
Set out. Give me 2.
All right, let's see. It is 1 because A is 001, right? So we set A to 001, and so it's 1. But now let's look at this one. So the only change in this code is that we're going to start with 2 elements in our slice. Everything else is the same other than there's an extra element there. So when we append to A, we're now at 4 elements with the 1, and when we append to B, we're now at 4 elements for B. So now let's print the 4th index in there, or that index 3. What's going to be printed out this time?
Now it's a 2.
I like this.
It's going to be still 1. Some people are saying 2. There's really only 2 options here, so it's one of those 2, and it is 2.
Yeah.
Does anybody know why?
Yeah, wait. Is it because this?
So you can do it. Send it.
I was gonna say, is it because on the first one the slice gets reallocated on the append?
Yeah, so slices are windows to an array.
Oh, good call.
In the first one, our array is just one size, and Go just picked it as one size, right? And then when we created B, it was just a window on that one. And then when we appended the A, it made that underline array bigger here, and then B created a new underline array that it appended to. But in this case, since B is just a window on that slice or on that array underneath, when we start with 2, it already made it big enough to hold all 4 of these indexes. And so when we appended to A, we added 1 to the 4th index on the array. And then we appended to B, it replaced that 4th index with 2 on the underline array. What?
There's the ownership shared between the 2.
Yeah, there's shared ownership there. So you gotta be careful. All right, this one is not interactive, but this is kind of a cool one. This is a rewrite of from context. I'm sure many people here have used context using some spooky Go features. So it's put it into 2 lines, but you can think of this as all 1 line of a generic version of this type. What we have in here is, we talked about method expressions earlier. So instead of doing ctx.value, we can work right off the type and then pass it in as the first value. We can put in an anonymous 0-sized struct, which is kind of a fun type of struct, takes no memory and is anonymous. And then we could also put this on the same line because Go is a C-like language. We can put it on the same line with just a semicolon. So you can get a little wild. Then the last one I have here is the fact that arrays can behave like maps, which is kind of a silly way. So we have this array of small primes, and it's going to be bool for each number, up to 40 we have here. So we could say, okay, the first index is false, false, 3 would be true, right? False, true. Then we could say, okay, 7's true, 11's true, 13's true, 17's true. Then we could go back to not putting the number if we wanted to and just say that 18 is false and 19 is true. This is like the cleverest code you could write. I would recommend never doing it. So that's some spooky Go for you. I hope you learned something that you probably won't use, but it's
What does it fill the rest of the array for those values? Are they just nil? Or
yeah, they're nil.
So they're false. Oh, gotcha.
One more question.
Oh, yeah.
Share out your slides like on the Slack.
On your JSON example, if you did export the S, I think you'd still just get the time. Yeah. Okay.
Awesome. Thank you, Boston. I did forgot to mention, if you did sign up for Lightning Talks, I posted the schedule on GoWestConf on the Forge Utah Slack, so you can pull that up and see what order you're going to be in.
There's also the link for sharing your screen there. So you need to add the Wi-Fi and join that link. Then if you go up there, I'll cast your slides up. Not your slides, your screen. Whatever your sharing mechanism of choice.
Okay, awesome. But next we have Carson Anderson with Go Interface Tips. Give it up for Carson.
Hey, I think the spookiest thing is following that talk because that was awesome. Stumped me. So I still know what I'm talking about. Maybe don't listen to what I'm going to say. So my name is Carson Anderson. I'm the on the developer experience team here at Weave. I call myself the DevXO because no one's told me I can't. I'm on that team and I kind of make sure stuff gets done. So recently we had a internal developer meetup, and I saw a lot of kind of bad practices or things I wanted people to avoid when they use Go interfaces. They're a fantastic tool. They're the reason you didn't need generics. They're the reason you probably still don't really need generics. We had a discussion during lunch, like you can use an interface, generics, promise you it's better. I want generics, it's just they're magic. But I see a lot of people using and misusing. So we're gonna go over some quick ideas about generics. I'll go a little bit quick over the basics, but hopefully you all kind of know how they work. Interfaces describe what something can do. That's it, right? Structs and all these other types describe data that describe what things are. Interfaces are just what are your behaviors. That's all that matters is how you behave. So say we've got a dog here that's got an age, and we've got a cat that's got an age, and they have some common shared behavior. Dogs and cats, completely separate creatures, but they have things that they can both do. Now I can of course create a dog and a cat separately and call methods on them. But what if I wanted to have a function that could take either or? I could do something really silly with generics now and overcomplicate my code. Run this to prove that my code works. Instead, I can say, well, there's a bunch of common behaviors. Rather than take a specific dog or a cat type, let's write a function. Let's actually write an interface that says, look, anything that can speak is going to be called an animal. You don't have to say that you're an animal. You just have a behavior and you can be that thing. So now I can create a slice of whatever, and anything that implements one method and call that. And I can pass that to functions. This is, I really stress this because you do not have to declare what you implement. Duck typing is sort of uber magic, and I don't know why anybody would want anything else. Some job a while back, I'm still bitter. So like say interfaces are duck type, you do not have to declare. So if I have a bunch of different interfaces, animal, liquor, age getter, and I have functions that take those three kinds of things, my dog interface my dog struct does not have to declare that it's three kinds of things. It just is because it is. It can do the things, so it is those things. So I can pass it without any sort of declaration. This is super magic. And I bring this up really for the next thing. There's a thing that a lot of us do in Go where we want compiler time errors a lot more whenever possible. So if I'm writing the dog struct, I'm writing the code to say I'm implementing dog and I intend dog to always be an animal. Even if I'm not using it like an animal right now, I want the compiler to warn me like, hey, I want to, and if I don't implement something the animal needs, tell me at compile time. And so if I run this right now, it works, but let's kind of move on and I'll show you a little bit of magic that I see all over the place that people mistake this. So this little bit of magic snippet up here is again a zero memory assignment that says, look, at compile time, try to coerce a nil pointer of dog into an animal. And people see this, come from other languages and think, I have to do this or dog isn't an animal, right? Like, no. So this is really great. It's absolutely not necessary. And it's only really useful in some very specific circumstances where you're writing something with the intention of implementing somebody else's interface. Okay? And you just want to have compile time warnings in case you don't. So if I do that now, it tells me, hey, dog's missing one of these behaviors that it has to have in order to be considered an animal. You can embed interfaces. So going briefly through, I know this is a lot of basics, but I know there's new people here. So rather than making lots of big interfaces, we'll come back to that, we can describe a age getter, which has one method, and I can describe an animal, simply embed all of the behaviors of age getter into the behaviors of an animal, and an animal can now it can speak and it can get age. You don't have to make multiple interfaces. You don't have to duplicate yourself, make tiny interfaces, and you compose them up into more complex behaviors. And the more you go, the more you realize the tinier the interface, the better. So the quick tips, errors in interface. I imagine we're going to talk a lot about this in the next upcoming panel, because this is sort of one of the things that gets people a lot, and they just underutilize errors, right? They're sending them around a lot. They're using them only in string format. And you think errors are magic because you use the errors new or you use the funct error f. Both of these things do return an error. And I bring this up because if you say, well, I've never used an interface in Go, you're lying because you use it all of the time. Every single time you receive an error, you're receiving an interface. So let's dive in. Error is, again, it's built into the language. It's a very one method interface. Have a method called error, return a string. Congratulations, you're now an error type in Go. In fact, that's all that really happens with any of the other packages. So we can make our own custom errors. I won't go too much into this. There's some really great examples online of essentially saying like anything that implements error can be returned back as an error. So use that data. Errors are not just like something that you should throw up and not use. You should actually make your own types, implement the interface, and then you can absolutely see I'm making an error here, and I'm assigning my custom struct. Struct can be an error. A function can be an error. Anything can be an error in Go. And you can, I'll show you later, actually go in and dig that data back out. So you're not just passing around these kind of opaque things, but you're using that data. So a more complex example is a file info error. So here's something where I say, pass me some information about a file. And then when someone prints my error, I'm going to use that information to build you a rich error message automatically. We'll use this in a second here. So I'm going to load some file information using OS stat. I'm going to make a new file info error and print it. And you can see I'm even doing some typecasting in here to say, okay, I can print it and just deal with it as an error, but I can also force that back into one of its original types and get data back out of it. So with one instruction, I get these very like rich errors that I can, if you don't care about the details, you can just pass them up and these become rich errors for your users. But if you really want to, you can dig in. This is where you keep error codes. This is where you keep like file line numbers, all of that kind of stuff. Keep your interfaces small. I've said this before, I'll say it again. A really big client sounds great because it can do all the things, but it becomes really, really hard to mock out. The bigger your interface, the harder it is, the less to implement, less useful that abstraction is. The smaller the abstraction, the more use it has. That's why error is so dang small. So like, well, I could do this if I wanted to pass something to the greet function. I have to implement a bunch of things, or I have to do a big no-no and Go, which is make a struct that embeds an interface. Pretend it implements a bunch of things that just panic when you try. I'm not going to go into that because you shouldn't do it unless your specific circumstances, usually unit tests. So what do I do instead of a big interface? Make a bunch of tiny ones. I use composition, right? I have a greeter that has one method. I have a lever that has one method. I have a greeter lever that combines those two together. I have a client that then does all of the things. So I still end up with this big client, but the functions that don't need everything from the client can use the tiny interfaces. And now I have way more flexible, reusable code. Again, I still get that big client, but this kind of composition just makes all your code better. Don't return interfaces. I see this a lot as well. When people don't realize duck typing exists in Go, they want to make functions that return interfaces rather than just the things that they are, right? So I've got my greeter lever. I've got a happy greeter that implements three things, right? Say hello, say goodbye, and tell time. So he technically implements all three of these interfaces. He just has some extra stuff. So if I were to make a constructor function that says, okay, give me a new happy greeter, and I precast it down. I say, here's a happy greeter, but I'm going to just give it back to you as this interface type. You're hiding a behavior that is there for exactly no value, right? That I always return a happy greeter. There's no reason to cast it into something smaller ahead of time, pre-scoping down the utility of this thing I'm returning. Because now I can't call tell time on, right? Because it's not the code thinks it's a just that interface. It's not its struct. So that doesn't work. So what do I do instead? Right, this is a really tiny change. Just stop returning interfaces. 99% of the time you don't need it. There is one exception I'll point out. In very rare circumstances, you want to have a constructor or something else that returns a choice of implementations of an interface, right? So I've got two kinds of greeters here that do different things. And maybe I want my function to take the relationship I have with a person. And based on the relationship, it's going to return one of two kinds of implementation. Then, of course, that's a great use for interface because I'm saying I'm going to choose what one of these two things is. It's not always the same thing. So I'm going to abstract that and return an interface. I've never done this in production. I'm just pointing out this is the only reason I think you should ever do this. But it works and it is a good reason. Just probably will never need it. That's it. I won't keep it for now. My GitHub is the slides. So.
Any questions for Carson?
Anybody? Yes.
So
with the small interface, do you ever find yourself doing that for third-party clients as well, where I need testability in this, so I'm taking their 90 method interface and rewriting my own interface that makes it
100% of the time. No, huge. So we do a lot of stuff. GitHub generates a great Go SDK where it has like a repositories service that has 60 things on it. We have a function that needs to do one of 60. And half the time you have a function that takes an interface, and right above it, we declare a private interface with the one thing we do from that third-party client. That's a fantastic use for interfaces and that's why duck typing is so great. Is I can have somebody else's code that doesn't know about mine fit into an interface I define. So yes, that's like one of my favorite uses of tiny interfaces, literally right above the function for third parties. Yeah.
Are there any pitfalls with doing that we should be aware of?
Not really. No, I mean, you have to keep this interface up with changes to the upstream, but that just, especially third parties, like that doesn't happen that often. You'd have to change your code anyway if that were to change. So I haven't really found any reason. Again, don't do that part. So I don't have a slide in here. Don't return interfaces and do not make one until you're using it as an interface, right? Like, so it's great to say, here's a third party thing. It can do 60 things. I do one, so I wrote an interface for that one thing. If you're not using that interface in a unit test, don't bother, right? Just take structs until you need the abstraction. That's my only, all this cool stuff with interfaces is wait until you use them as an interface to even write them as an interface. So, good question. Yeah.
So I know saying anything good about Java is basically heresy, but I do enjoy that even though you have to pass interfaces around, you can write a Lambda if it's a single method interface. And Go doesn't have that. I know there's talked about it, but I'm curious, like the, let's see, I think the HTTP handler func or handler has like that sort of pattern where it's an interface with one method, but then there's a type that's just the function so that it's easier to pass in functions. Have you found yourself using that ever so that it's easier to compose these small ones? Like, do you create a type along with the interface so that it's easier to pass in functions for these small interfaces, or has that not been so useful for you?
It's you're right. It is, and there's very specific cases like that where it's really nice, and HTTP handle function is what you're referring to, right? Where like HTTP server takes a handler that has to implement one thing, and sometimes it's nice to just pass a function and it casts it into a little wrapper. That's almost the only time I use that. I think it's sometimes really big data processing where you're making Lambda-like things. But generally speaking, it just doesn't come up a ton. So, cool. Well, thanks everybody.
Okay, awesome. Thank you, Carson. Next, we have AJ O'Neill with a talk called Webby and Go Releaser.
Question. Yeah. Share your screen up with the slides up. Can you figure out how to share your screen if you want?
Oh, I share my screen not via coffee and cable, but via web.
You're on the call, so you can share screen button.
I'm gonna press share screen, and I should I be I should be muted here.
Yes.
Muted here, but I can start camera and then share.
If you want your camera on, just press share screen and it should.
Share screen. Share screen.
I think what they, so I actually think that there's a couple articles like this.
Like that superhero guy with the button choices. Screen share window.
There you go.
All right, so everybody can see what I've got up here. Great. So, Webby, you had a little bit of introduction to earlier. It's basically install stuff with one line from the official maintainer, and all it does is select the tarball from whatever their releases JSON is, downloads it, puts it in the path, adds the path to your shell variables, and it works for the various shells. So that's kind of the basics of it. There's no sudo required. It doesn't change permissions. It doesn't require a package manager. It doesn't have to update. It's like literally go fetch the JSON releases, download the latest file or whatever file matches whatever you put after the at and so on. Okay, so that's what Webby is, and I introduced that first this morning. And the idea is that you should have all of your developer tools should be just one command away from installing. So Go Releaser is
something that first of all, who is not using GoReleaser? This is not shame. This is just, okay, so about half the room's not using GoReleaser. Okay. So does anybody, well, okay. I hope to help you with that because GoReleaser is perhaps, it's one of the most awesome tools that we have. It is build my code for a matrix of platforms and architectures, operating systems and architectures, and upload to GitHub releases or another releases API. So it supports multiple releases APIs, and you can do a matrix with it. So I'm just going to show you from the cheat sheet that I have. So another thing about Webby is that because I use it with clients, it started as a way for me to limit documentation of like, how do you get X installed? Follow these 10 easy instructions, update your path, and hope that your computer's in the right environment. But so everything has a cheat sheet on it, and so I have a cheat sheet for GoReleaser. And basically, once you've installed GoReleaser, you want to create a .goreleaser.yaml, which you do by doing GoReleaser init, and then the command that is kind of your dry run command is this right here: GoReleaser snapshot skip publish rm dist. And so what this is going to allow you to do is to test your build as it currently exists. And so go build of course should work for the project. We'll go through a little bit what it looks like. So you can have version information directly embedded in your code. You'll notice many of the tools that you get that are Go tools, they have Go version information that most likely came from GoReleaser. So you have version date and commit, some information that eventually will get printed out on the command line. You figure out how you want to print it on the command line. But I just want to show you embed that information. And then you have your program, it does whatever it does, and hopefully it has a version command that will print that out. So when GoReleaser runs, unless you tell it to do otherwise, it will replace those with the get tag and the date and the commit hash. And you will need to have a GitHub token. There's a link here to directly to go to your GitHub tokens. So let's see, there we go. So you create a token that has repo permissions. Just gonna do that. Now everybody can see my token. Now I'm going to delete it. I just wanted to show you how to print it. And then you can either export your GitHub token or you can put it in a file under. So a lot of people don't know this. If you're creating a command line tool, your configuration should go under .config. That is the standard. So if you're creating a tool called BOGO, your config should not be in home.bogo. Your config should be in .config/bogo. Just pro tip. The early Unix tools didn't do that, but now we know better. So anyway, so you put your GitHub token as just a plain string into your GitHub token file, and then you tag in your Git repository and you push. So the only things that you weren't already doing, hopefully, was that you've never run GoReleaser init before, and you may not have a file on your computer called GitHub token in the config directory for GoReleaser. And then what the config needs to look like, let me just get down here. So you can build for Raspberry Pi, you can build for lots of architecture. So this is kind of what it looks like. You generally want to set cgo enabled equals 0, which means that you're not going to include libc on Linux. You're not going to link to the system libraries on Mac OS. You're not going to link to MSVC on Windows, which means that your thing is just going to run. It can run in Docker, in a bare Docker image. It will run on anybody's computer, regardless of how old or how new it is, with basically just the constraints of the kernel, which change not that frequently. And then you define your matrix for your GoOS. So GoOS, your GoArch, which I think we can kind of safely take 386 out of the list now, but when I wrote this, it was still sometimes a thing. And then GoArm, which again, I think we can kind of take this out of the list now because I think everything's on ARM 8, which is ARM 64. Anyway, so you have a build matrix that looks like this. And if that's all you have for your build matrix, then it's going to work. And if you have like a command directory, many projects, you might have more than one bin tool that you build, or you might just like the convention of putting your bin tool under command, then you can tell it how to run the Go build so that it will actually build your command. So here's an example of that. You can tell it what you want the binary to be named. You can also, in another example, I think I showed how to choose whether it's zip or tar. So I'm just going to scroll down here. So this is the more complete example. This is using cross compiling where there's a C tool chain, and like this has got all the fixins in it where you have to pass C flags. This is like the really, really complicated example. It is 2 pages long, but it's not that complicated. And it looks like I did not actually include in my cheat sheet how you do the tar versus zip, so I will update that. But anyway, or maybe I did later down. Let me see. I have a few different examples here under different headings. All the way at the top, there is a heading, basic usage, publishing to GitHub, publishing to Git and GitLab, Raspberry Pi, et cetera, et cetera. So you can kind of find the one that fits your use case, kind of take a peek at that. Oh, okay. In the one down at the bottom, I do have the archive section, and it shows, okay, for Windows, we want zip, but for Darwin and for Linux, we just want the default, which is going to be a tar. So point of all this is that if your code builds, and you build a binary, and you want to be able to distribute it, you created a developer tool, you want people to have access to it. If you use GoReleaser, then you can easily push it to GitHub releases, where the only steps people need to do are to download it from their releases, unpack it, put it into a folder that's in their path, and they're off to the races. And if you want to eliminate those steps, then you can basically copy and paste from any of the tools on Webby that were built with GoReleaser, and that's in the documentation. Do a find and replace with its name, with your tool's name, and then all people have to do is copy and paste one line. So anyway, I think GoReleaser is great. I think you've probably got some cool tools you've built for yourself you could make more accessible to other people, and I hope that you will use GoReleaser to do that.
Any questions for AJ? Yeah, Paul.
So how would you create a SHA or sign like a Windows or a Darwin build using GoReleaser?
Okay, so that is probably outside of the scope of GoReleaser. If you're looking at signed binaries, so one on Mac, you don't actually need your binary to be signed. You just need to have in your install script to run to take off the quarantine bit. Windows, generally command line tools don't need to be signed. So I'm thinking command line tools. I'm not thinking UIs. So I don't know. You might be able to find out documentation. I've never used it.
So there's not like a call out type directive in GoReleaser to go out to some other tool or whatever.
GoReleaser has hooks. In fact, a lot of people that do Rust CLI tools use GoReleaser. But that is something that's outside of the realm of what I foresee. Is anybody convinced to release a tool of GoReleaser? It's okay if I only see one hand. I just need to see one.
I mean, I'll use it, but I don't release things. So. Next time I will.
All right, thank you.
All right, thank you, AJ. Let's give him a hand. All right, yeah, next up is Adam Wetton with some precision advertising.
All right. I just wanted to take this time to introduce what agility is, what we're doing, what we're building. It's not one of those household names among software engineers in the Valley yet. Hence why I'm going to introduce it to you guys so you can see why it's so exciting what we're doing. And again, we're hiring. So if this is interesting to you, come talk to me. Find me on the Force Tech Slack channel stuff or whatever. So yeah, agility. We're precision advertising. So what does that mean? Because of developments in marketing technology, we're living through a true paradigm shift. Platforms like Netflix, Disney Plus, and Spotify are offering ad inventory on the open internet rather than the walled garden approach like Google and Meta. Eventually, all platforms will need to follow to remain competitive. The availability of this inventory on the open internet creates an opportunity for someone to integrate all of the best audience data available and ride the crest of the wave. Precision advertising is that solution. Oh, there we go. Many CMOs we work with are navigating the challenges of choosing where to focus marketing efforts. They need a way to integrate brand building and performance marketing. Marketing teams often focus their marketing dollars and lower in the funnel on direct response, which is always meant immediate response because it is easier to measure. But it comes at the expense of building your brand and reaching new audiences. Advertising on the open internet creates an opportunity to measure and connect every touch point in the buyer's journey. Companies are able to become unforgettable by reaching customers wherever they are on the internet throughout their buying journey. Now, I know a lot of people, when I talk about precision or this type of advertising, people think, oh, you guys are the bad guys, people we don't like. We're seeing ads that are relevant to what I want. That's the point. You know, why would you want to see an ad for a dating website if you're married, for example? Hopefully you wouldn't want that. Not that I'm judging. Anyways. Sorry. Reaching customers at every touch point in their journey can finally be direct response because direct marketing impact on revenue can be measured. This has been something that's been very difficult in the industry. You can know which touch points matter the most in the buying journey. Marketing strategies still must be direct response, but direct response no longer has to mean immediate response. It means knowing how each touch point directly drove revenue and how to shift budget across all touch points for any given subgroup of your prospects. Companies can optimize across the entire mix of ad experiences to drive the most revenue from each marketing dollar. Sorry, I got 2 slides open, one for my notes, because you know the guys who do the best presenting at the company to our clients, they can write this out better than I could. So that is why we built Agility's precision advertising platform. Great businesses must influence every moment with one platform and work in concert with every other channel to drive down CAC or customer acquisition costs. I didn't know that before. Grow revenue and increase profitability. So Agility's platform makes precision advertising possible with the unique combination of industry-wide audience data integration, full access to the open internet, including all media types, devices, and millions of channels, systematic creative production to make the scale of precision advertising even possible, and enterprise-grade data science modeling so that full funnel advertising can produce direct response level efficiency. There's an example from here, but just to kind of save on time, we're building something that nobody else does, even like the top giants in this space. And as I mentioned, this is a $500 billion industry. Kind of some background on Agility: started as an advertising agency. They decided to build their own tech. The original guys who decided that didn't really know how to do that, how to run a tech industry type business. In the last year, we've transformed a lot, identified this path moving forward, proven that it works with our target customers. With 42 employees, this year we're on track to generate around 20 million in revenue without any funding. And what's in the pipeline for 2024 is really incredible. So if you want to ride that wave with us, feel free to reach out to me on the Forge Tech Slack stuff, Adam Wetton. You could also connect with me while you're here. Regardless, keep us in mind, look out for us, because the growth that we're anticipating is pretty incredible. A lot of fun things to work on. Like I said, we have 2 backend engineers, and there's a lot of good stuff to do. So please reach out to me. But yeah, that's it.
Any questions for Adam?
Is it Brandon go?
Yes. Yeah. Back in Brandon go. Question. Thank goodness, right?
Yeah.
Okay, awesome. Thank you, Adam. Also, isn't it 2 out of 2 back-end engineers are named Adam?
Yes.
So if you know any other Adams?
You don't have to be though.
Okay, next up we have Zach Walton with a talk called "Who Really Made This?"
Thank goodness,
As long as your computer speakers up.
Permission.
Give me 1 second, y'all. Technical difficulties because it's a presentation. quit and reopen. That's great. I'm enjoying again. Or would you confirm I was kicked off of the? No, I think it was, I had to give permissions.
As long as you join again, I think.
Y'all hear me? Can't find my microphone. That's good. Starting real well.
Oh, thanks.
As long as, yeah. Only does it for tab. No, that's what I'm saying.
Yeah, I'm taking that with you. Here we go. First off, just really quick shout out to Brandon for your team. He's going to help you get through a lot of this. Not Go related, the rest of my presentation, but that's like the only Go related thing. So I thought I'd give it a shout out quick. Thanks for being here, everyone. I'm Zach Walton, a software
It's not sure.
Oh, it's not. And that's how they get you. Can't share your screen. Chat. I'm gonna plug in.
See if this decides to work. If not, we may go to the next call.
Is that showing?
No, it's not up.
So anyone know any good jokes or something? Icebreakers?
They go to the next talk and then come back.
Y'all hear the one about the tech demo that did work in a presentation? Either. Are we showing now or no?
No, we're not. Go to the next talk. And we'll...
Well, and that was my presentation.
Okay, next up is, oh, I forgot. Okay, Angel Beltran. Is that how you say it?
Yeah.
Okay, awesome. And he is doing HTMX plus Go.
I haven't connected either yet, so we'll see how this goes. Fingers.
Did you join the StreamYard thing? Let's get you on there to your screen. My capture card exploded. Not literally, emotionally.
So I think I got the link.
Yeah, just a lot.
Okay.
Emotionally blue.
Oh, you're not gonna show anything.
Okay. I'm like, well, it doesn't matter. I'm on camera. Okay. Okay.
And share, screen share, slide share.
Cool. Then mute it. Right. Mhm. Then redo Chrome. Okay. Oh, wait, re-up. Should. That used to be my background. I made it as a name and that opportunity. Everyone loves it. I got it around here.
Sorry, some of my hardware was closed, but we always use software as backup, right? At a conference.
Yeah, you heard this first one.
Thank you. There we go. Okay. Hope that's sharing.
It will be. I just have to add you. Now you're added to the state. We're good.
Yeah.
Oh, oops. Sorry. It's on the live stream. I need to present again. Present.
Well, this is gonna be a fun presentation. Okay. Okay, so forgive me if this is a little bit unprepared. This is kind of I heard, hey, there's time to share whatever you want. So I thought, cool, I can do that for 5 minutes. What I'm going to be sharing is a little bit of playing around with HTMX and Go. And so if you're like me, you're not a huge fan of having to work on the front end. You don't like to play around with JavaScript all too much if you can help it. And if you're also like me, you have to use an SPA framework like Vue or React. You're kind of boxed in there. And they solve a lot of problems. They provide a lot of front-end functionality and whatnot, but with them comes a lot of compilation, a big process of minifying, uglifying, and all that, and then uploading and so on and so forth. And it comes with some other costs like you lose SEO optimization when you have a giant SPA too. So and for someone who likes just making web pages occasionally with raw HTML CSS, this is kind of a bit of a fun tool that says, hey, we're just gonna add a little bit of functionality to HTMX. So you can actually install it with a small little script. I think it's 10K, so it's pretty small and cacheable. We'll add a little functionality to HTML that allows you to do some things that unfortunately the HTML spec doesn't allow for. So like linking is only done via A tags and submission is only done through forms. This says, well, what if you just have a button you wanted to do a post or a put or patch? This allows that. So you can, so it has some fun little tags like hx-post and some other things that say, hey, this button is clickable. When you do it, call this endpoint, and so on and so forth. And since we're trying to avoid having unnecessary JavaScript, well, unnecessary is an opinion, but we're trying to dedicate too much work and effort to developing a front end. We're trying to avoid, trying to keep things as much, what would you say? Trying not to have a dedicated front end framework to some sense. Let's just return the HTML that the page is going to render. So if this isn't your cup of tea, then this isn't the tool for you. But so I'm just going to read through this really quick and then go to a couple of fun little examples and then a little project that I was working on that I thought might be fun to share. So HTMX is a library that allows you to access modern browser features directly from HTML rather than using JavaScript. To understand HTMX, first let's look at an anchor tag. This anchor tag tells the browser, when the user clicks on this link, issue an HTTP GET request to the blog and load the response content into the browser window. So the notable difference is this isn't going to result in a redirect, which classically you would expect. So what will happen instead is this HTML will be replaced with whatever the response is. So that can be nice for dynamic content, but you don't want to have to have any JavaScript that says, oh, when you click this, re-render this, Vue, Angular, whatever it might be. You could just have an endpoint that says, oh, here's your HTML, load. You got to deal with potentially response times if you're serving content around the world and whatnot, but that could be really nice when you say, oh, it's just a simple set of content. And likewise, with that in mind, considering the following bit of HTML, you have a button where when you click it, it should end up calling this endpoint /click, whatnot. And in this example also, it says, this is the content we're going to swap out. You got a CSS identifier, parent div, and we're going to replace the whole thing with this. Now, the parent div's not in the picture here, but that's the gist of it. So the tool, from what I understand, I'm just learning how to use it myself, tinkering around with it, but as I see it, it's a nice way for you to go avoid some of these heavy JavaScript tools that require all this setup and all this integration, and try to keep it as minimal as possible until you need the tool. Kind of like the database conversation we had earlier, where let's start with something simple and then go to something that scales when you need it. And so I'm just going to pull up an example. Hope I can do this with one hand. A little example that I made in the time that I had here. So here's one that I made offhand. I'm importing HTMX. All this page has is a bit of content. You got an H1, a paragraph, and a button. And so if I get this right. There we go. So I'm going to replace the content here. I didn't write any JavaScript. When I click this, the title's wrong, but it's not going to actually fetch Google. I was trying to do that, but Core's got in the way. When I click that, it's going to replace it with the content there. No JavaScript involved, so that's the whole benefit of it. And what you'll notice is what that content was simply another HTML file. So here's the button that was rendered on the screen originally. When I clicked it, defined by this HX trigger tag, it fetched this HTML. You can actually see the request here. I got a little Python server running. It fetched that URL and it swapped the entirety of the button with the outer HTML. And that's kind of cool too. If I get rid of that and redo it, instead it will by default replace the inner HTML. So now it's inside the button. It's kind of fun. So you can dedicate all sorts of little things like that. Pretty customizable, pretty fun. Where I think it's kind of fun to explore, and I've seen this some other people in the space tinkering around with this, is combining with Go templating. So you can create dynamic content. So your user has a session, possibly stored in the cookie, to some web token and whatnot. And then whenever you get a request, you simply look at the server state, the URL, query parameters and whatnot, and you generate the HTML on the fly. So I'll wrap this up with just my little example. Let me see if I get to that. Cool. So this is a little page I've been tinkering with a bit. So I'm just gonna navigate to a page here, and I haven't actually built any game, but as part of it, what you got here is, okay, I'm gonna actually jump into a game. It's not fully set up or anything. This is based on a board game called Agricola. If you're a fan of it, that's awesome. But otherwise, here's a little example that I have of how you would go about doing it. If it's not your kind of thing, then you know. What I have here is a bit of content here that's based on the user at hand. So this is a user, my wife added crazy cougar something or other. And these are some playing cards that the player has. And this HTML here, if I can actually load it up, one sec. Is dynamically fetched every time I click this link. So let me do a quick refresh here. There we go. Cool. So when I click this link, this does a get on a specific endpoint that retrieves this HTML, returns it back, and here's actually a little response there. There's the raw HTML. You see that now it's got the links are at the bottom. This one's clickable because it has an href, and there's the stuff too. If I click previous, it'll fetch it again on the previous page. And yeah, I guess that's that. Try to keep it at that length, and awesome. Thanks for letting me share.
Oh, yep. Hey, how's it going, everyone? Gotta say I'm a bit nervous. I've never presented twice at a conference. So first time.
Open.
But I guess it's like just use a little bit.
Yeah, you don't have PowerPoint on there, do you? See how this works? Not on PowerPoint. Microsoft is notorious for working well with Mac though, so it should go great.
Only.
Honestly, if you just play one of them, should be fine.
See, you would think. 1 minute.
Nope, okay.
This- I don't know. Come over here. It's the audio sharing that's gonna be fun. I think desktop audio is going to monitor. The monitor is going to if you can hear me. Going to that. Going to black hole. And then black hole is my output device. I need it to be the mic. So using that.
Testing. Correct.
Right, stop. This will be circular.
see the Go community growing in Utah. Been going to Go meetups in Utah since like 2014. It was a much different crowd back then. We were meeting up at I forget the name of that place. Yeah, Rakuten up in Common Heights area, their space, and it's kind of neat to travel around. And it's awesome to be here at the local Go conference in Utah. So that's super awesome. It's what a great community. A little bit about myself. There we go. I've been writing software since I could talk, almost. Not quite true, but for a really long time. Got a PhD in electrical engineering from Purdue, so I love the Game Boy Advance talk. I love hardware. I don't get to work on hardware very much anymore. I'm not as motivated as some people are to get into the dark corners of the internet and work on things just because you can. But it's a little inspiring. Love software. That's why I'm working in software. I love observability systems. Tracing is like one of my favorite things ever to work on. So whenever I get a chance to work on a tracing system, I'm like, this is the greatest thing ever. How fun. Most people don't say that. Love to ski. Trying to get into surfing. Not good at it. I got some Google stock photo pictures on the side there. None of those are of me or things I've worked on, but they represent my interests. My hobby is programming. So like Nate and I like sit on program for fun. Super fun. I work for a company called Kala. We're hoping to make integrations a whole lot easier for people because let's be honest, they're a nightmare. They're all bespoke. They're all a mess. So Clint and I over here started a company called Kala. We are working on an integration platform. We want to be the Zapier for all the integrations that Zapier won't ever touch because they're horrible. But that's kind of what we're working on. So give us a look if you want to see more of what we're doing. We've got a new landing page coming up soon, so it'll actually describe what we're doing instead of what we thought we were going to be doing. All right, let's get into testing. Raise your hand if testing is your favorite part of your job. Awesome. Cool. Testing is cool, right? It's super cool. It's super awesome. Like we should all just do testing. Why do we do testing? Because we want to develop code faster, right? We want to get our code out faster. We want to see the outcome of our code. We want to do things faster. So like, if you have good testing strategies, you can do things really fast. If you want to do things really slow, what you do is you write your code, you commit it, push it to GitHub or GitLab. You wait for your CI/CD system to run, maybe get it up on a box somewhere else. Go and hit a URL by hand, and then later, like, yeah, code didn't work. All right, do that again. Like, that's not fun. So when we're talking about testing, I'm not talking about stuff like that. Why do we do testing? Because we want to deliver value. That's why we're getting paid to do this, is to deliver value to someone. It's our customers, our employer, or someone. Someone's paying us to do this. So it's our responsibility to deliver that value quickly and efficiently. We do testing because it's part of our code storytelling. We went to a great talk at GoWestConf. It was really inspiring. She talked about writing code as telling a story. And you want to write your code clear, concisely. You want it structured so that when someone comes in a year later, 2 years later, next week, they can go through and they can read it and understand what's going on. So that means having the right layers of abstraction in the right places. So that when you're looking at a function, you're like, oh yeah, Sally went to the market, Sally got in her car, Sally bought some lettuce, Sally went home and made a sandwich, right? That means awesome. No one wants to read a story and say, oh, Sally got in her car, she opened the door, she put the key in the ignition, she turned it, she pushed on the gas pedal, she steered, she walked in the store, it took 20 steps to do that. Like no one wants to read at that level of detail when they just want to know, what is Sally doing, right? So right level abstraction, right places. If you want more details, you can dive into functions and find those details elsewhere, but maybe not in the main part of the story on what you're doing. So that was super cool. And it really works well with testing because if you have good storytelling in your code, it makes testing a whole lot easier. We do testing because we want to manage the risk of delivering our new code, right? You can write a bunch of code and just YOLO, throw it over the fence and say, I'm done, this is great. And then hour later, you hear people screaming down support and they're like, oh no, what's happening? Our phone lines are overloaded. We can't do anything, right? And you're like, yes, I won. Could be fun. Testing helps us maintain code quality. That goes back to the storytelling. So if you have testable code, your code quality is likely to be better because you actually put some thought into the structure of your code.
And then the testing around our code, it also provides context to what our code is supposed to be doing. So if you want to see how a function's supposed to be used, sometimes you can turn to the tests that are written around it and say, oh, that's how it was intended to be used. And I'm not using it that way. And that might be why I'm having problems with it. It's because it wasn't built in that context of what I'm trying to do. Or maybe you can say, oh, if I hold it a little bit differently, it'll work a little bit smoother for me. So those are all some of the reasons why we do testing. Hopefully it kind of broadens our views of it. That's a empty slide. Oh, it has a transition. Yes, cool, transitions. Testing is a whole wide spectrum that we have to navigate, right? There's so many different types of testing that we can do and should be doing. And it really depends on the context that we're working under. Testing's more than just having a unit test. Testing's more than just having a QA engineer who's going to review your code for you, right? There's a whole spectrum to testing. We have unit tests. Unit tests are small, they're focused, they have minimal dependencies. They're part of our code coverage analysis reports that some of our DevX people force on us. And they really shape how we write our code. We have integration tests. Those are broader. They involve multiple systems. They guarantee that your code is working well with the database, it's working well with the cache, it's working well with the ingress router, working well with all those other pieces and components that are all outside the scope of your direct code. We have non-functional tests. These are going to be security requirements. Are we restricting access to people who shouldn't have access to things? Are we creating audit logs we're supposed to? Are we feeding the data into the SIM system for the security people so they can fire off alerts when they notice someone's just crawled over 1 million profiles, right? That's kind of a non-functional. It's not for the product, but it's for the auxiliary operations of the company. We have performance, scalability, availability testing. Can our code scale? Can it handle the load that we expect it to have today? Will it be able to handle the load we expect it to have in a year or 2 years, right? That's a different type of testing than unit testing. And then availability, is our code still running? Like, I don't know, is my code running? Maybe. And then user acceptance testing. Does it provide joy to our customers to use our code? Does it meet the checklist that our product and designer people, set out to give us? These are all the different types of testing to work on and to navigate. And we need to make sure that we don't have a really narrow view of what we consider to be testing. All right, so how do we establish a testing strategy, right? I think in general, especially for me, like I don't spend enough time thinking about what my testing strategies are going to be up front. And sometimes they get pushed off to be an afterthought. And so came up with a bunch of ideas of things we should be thinking about as we're writing new code to determine what our testing strategy should be. Is it something we're going to throw over the wall to our QA testers and say, hey, you know what? There's too many things involved and it's not worth the company's time for me to write unit tests because I have to mock out 30 services. Maybe it's okay to push that off to a QA person and be a part of a manual thing. Or maybe there's something else. And it's like, yeah, this is a unit test because I need it because it's going to get called 1 million times a second. And it has to work every time. Love those transitions. Okay, we need to understand the context that our change is happening under. Is it new code that we're working on? Is it old code? Is our new code that we're working on today going to become old code in a week and we're still working on it and then we forgot the stuff we worked on earlier? Yeah, we need to understand that. We need to understand how much investment the company is going to make in this set of tickets that we're working on. So we pull a ticket off of our ticketing system. How much time does the company want us to work on it? How much time is budgeted for it? If they budgeted it a day for it and we take 2 weeks on it, that's not cool. It's going to get us in trouble, right? No one's going to be happy with that. How much cognitive load are we introducing into the system with our changes? Maybe we want to refactor a little bit more so that we can make sure that the next person come in doesn't get like ambushed by, oh, this code's all about this one feature, except this section of code here is totally different, and I'm not sure what's related, and there's no comments, and I don't understand what's going on here, and I'm just terrified to death to work on this code. Who's the code for? What's it for? How often is this code going to be worked on? That can also impact it too. Is the code going to be touched again in the next year? Is there like a well-developed roadmap where there's like 5 phases of the project that are going to be followed up on this particular code? That all impacts on how we code it and how we test it. How much risk is associated with the change? Is this going into a high volume pipeline where if I stutter, if the code stutters and takes a little bit longer, it's going to just cause a huge backlog in our pipeline? Or is it, a sign up form and it doesn't matter if I introduce latency because the user doesn't really care if it takes 10 milliseconds longer to sign up because we only have one person sign up a day. Like, does it matter? How much support costs are we going to incur from it? What's our operational budget? Are we introducing a new call to some cloud service and is it going to end up costing $1 million a year? Right? Lots of context. And the most important thing to keep in mind is the context is always changing. The way your code is used today may not be the way it's used in a year or 2 years. Your company may look completely differently. And you gotta just understand that the context is always changing. So we make reasonable forecasts, we make our best effort. We don't build out a whole bunch of code that's not going to be used with like 10 new services. It's like, oh yeah, this is all dead code, but maybe in a year it'll get used. Famous saying, you're not going to need it until you need it, so don't build it until you need it. And if people talk bad about your code that you wrote a year ago, just smile and say, you know what, it's in use, it's making money. So that's good code. Good code makes money. All right. How much should the company invest in it? This is a kind of a complicated topic because if you're given all the time in the world to work on a product feature, you can build the best testing framework ever around it. It'll be phenomenal. You can orchestrate containers coming up left and right and seeding in data and, simulating users and load, and you can just do everything, right? But is that valuable to the company? It depends, right? It totally depends. If it's it could be worth a lot of money to the company, or it might be like, hey, you know what? You get 10 minutes and move on. Yeah. And so you have all these different things. The most dangerous situation to be in is when the budget you're allocated, because to be honest, all your time's allocated by the company. It's when the budget and time you're allocated for a ticket is misaligned with the risk of the change that you're making. That's dangerous territory to be in. And that's when you need to start having discussions with people to help either you or them understand how to bridge the gap between the budget, which is time, and the amount of risk that's being introduced, and make sure you bridge that gap beforehand, because no one wants angry customers. No one wants the company to lose money. No one wants bad things to happen. So that's a conversation starter. How much testing is enough? It depends. The best part is that no matter what you do, all your code's going to get tested. It may be by you, it may be by your CI/CD system, it may be by your customers, it could be by the CEO in front of a board meeting, right? Like, you don't know, but it's going to get tested. And so you need to make a conscious decision about who's going to be testing your code for you. The best type of testing is the automated testing that's done in unit tests, but that's really hard sometimes because of dependencies and complexity. But just keep that in mind. Something to consider. I think we covered this. So how much testing questions you ask? It's like determine how much risk is involved in the change that you're making. Lots of risk, you need more tests. If you're in code that hasn't been touched for 2 or 3 years and you look at it and it looks like a foreign language, and you look at it and all the naming's weird because the vocabulary in the company's changed and you don't use those words in the company anymore, and you're like, I don't know what a subscriber means in this context. I don't know what an inventory item is. It's like, this is like totally foreign, just totally like out of your league. You're like, I have no idea. That's a lot of risk. Probably need more tests. If there's a lot more planned future work on it, meaning a lot of people are going to be coming in and touching this code, you probably want some tests around it to set the context around your code and what it was meant to do. Lots of times we make assumptions about things and code and the way it should behave. And sometimes those assumptions are wrong. And it's really nice to be able to guide future people and constrain them, saying, here's what this code is supposed to do. Here's what it's not supposed to do. That's enforced by tests and throwing errors in the code and just making it a friendly code to be worked with. Okay, this is my favorite part. What counts as a test, right? Unit tests. Unit tests count as tests, right? What about when you throw it up into like your GUI and you load the website, you look at it with your eyes, right? Well, that's another test, very manual test. Every time it gets used, every time your code gets run, it's some type of test. So like I've got a very broad definition of tests, and we just need to keep that in mind. Got lots and lots of tools that are available for testing. Observability tools are a great item for testing because those give you your operational behavior tests, right? Your metrics, your tracing, your alerts, your logs. Those are all things that you can observe to know how your code is working, and you can trigger alerts and errors based off of the outputs of all those things to know, is my code working as it's intended to be working? Especially when you have things like in Go where you have, it's really easy to introduce leaking Go routines or leaking memory or leaking file handles. That's where metrics are super important as part of your testing or observability. So you can know, yes, I am leaking Go routines. I got to go fix something somewhere, otherwise my app's going to crash. Or, nah, my memory's in check. My Go routines are in check. My file handles are in check. This is good. Good code. Benchmarking for performance critical testing. Benchmarking is super useful. A lot of people, I know I'm not necessarily involved in it, but benchmarking is not super important for my line of work. But if you're working on a database system or a high throughput system, plus thing, you want benchmarking. So you know, here's the performance before my change, here's the performance after my change. Okay, they line up straight. End user testing. Especially when we're developing new product features, we have beta customers or alpha customers or like a private preview. That's all part of our testing. It helps us test our user experience. It helps test the functionality. Our customers are always going to surprise us because they can go in with certain assumptions about how things are going to work. They're going to go around, they're going to click in weird places, they're going to put weird data in. And sometimes as a developer, like, oh no, the path is clear. We do A, B, and C. The customer comes in and says, no, I'm going to do E, F, G, and then Z. You're like, oh, okay. I'm going to change things. We're going to make this better. YOLO testing. Lots of times they do that. You're like, it doesn't matter. Just deploy it. If someone screams fire, then I know that I need to go fix it, but maybe not. YOLO testing, like, it's useful if I'm like, okay, I'm 99.9% sure based off of my metrics and everything that this code is dead. And then the last step is to delete the code. That's kind of like falls into this category because you're not 100% sure the code's dead, but you delete it, you deploy it, you cross your fingers, you watch the support channels, and you're like, okay, we're good. Or you're like, oh, that report that runs once a week that I missed my metrics, it depends on my endpoints. You're like, okay, I'm going to fix that. But like sometimes getting to 100% confidence isn't the right answer because it's too expensive to get there. So sometimes you just have to throw it over the wall and see what happens. Other side, we get more into our actual code vetting and code analysis. GoVet is a super cool tool. I love that it's built in. It catches a lot of silly mistakes in Go, which is phenomenal. It's like, hey, you're shadowing this variable, or hey, you've got this unused variable here. You know, just all of those types of things. There's a whole bunch of linters that are available for Go2 as add-ons that can enforce for specific code style guides. So definitely take advantage of those. Unit tests, phenomenal that Go has unit tests built in. It's not super common in older languages. So if you're looking at like Node or C++ or whatnot, you've got like 30 choices for what unit testing framework to use. And you're like, I don't even know where to start. And then it's like, okay, let's have a 3-week discussion with the team, decide which one we want to use, or then you use it and like, oh, it's not quite right. So super awesome that Go has it built in, and everyone's just kind of like, well, this is just the way it is, and we're stuck with it. And so no choice is helpful sometimes. Fuzzing recently got introduced in Go. It's one of those things super awesome for certain use cases. Integration tests, those are your end-to-end testing, manual testing, staged rollouts through different environments or cells of your infrastructure. Super awesome because it helps build confidence in your code as you deploy it to more and more people. Because it's testing is all about managing our risk. And so as we build confidence, we can roll it out to more and more people. So having staged rollouts or multiple cells that you deploy into would be super useful because it kind of, slows it out. Feature flags, super awesome too, because you can get your code out in production so fast. You don't have to do integration testing. You don't have to do manual testing. It's like your code's just there, and you flip the switch for your user, and then you get this special experience just for you within this fully integrated environment. Super helpful. Private beta customers allows the slow rollout for testing, for new features, and get private users. It's a great tool to use for testing. When you've decided on your testing strategy, so you're going to go through that list, and you're going to pick like 7 or 8 things, maybe, or maybe one, or maybe all of them. You ought to document it because you've got all this information in your head about here's how I, as the developer, developed this strategy for mitigating or managing the risk of the process of this code. And next week, or in a month, or in a year, the next developer to come in, you need to hand off that information to them. So you need to be able to document your code, document your testing strategy, so that others know that the test exists and that they can reproduce those tests. If it's in a PR comment, that can be really hard to find in a year when someone comes in code because they might not even know that PR exists. So just even including a link to the PR in your code and the comment around it, it's like, hey, this code's pretty nasty and tricky, but here's a link on how I did some manual testing to supplement the unit testing that's here. Super useful. I wish I saw that more often, so I highly encourage you to just dump your brain into comments, like super useful. And if people in the future don't find it valuable, they can just go in and delete it. All right, Go toolchain, as we mentioned, has a lot of stuff built into it. We've got formatting, embedding, and unit testing, fuzzing, benchmarking. So we'll kind of get into a little bit of that. Maintainable applications are applications that are easily tested. You've got a whole bunch of frameworks and guidelines for ways to guide us towards more maintainable applications. Factor apps, principles in there. Clean is another framework. Dry, wet, solid, test-driven development. Like these are all tools that we can use to help shape the way our code looks. And then when we add unit tests, it helps shape our code too. Most of our code, if you're doing like web APIs or any type of web apps code, your code ends up looking pretty similar to this. You've got an API handler. You're going to massage the input data a little bit. You're going to do some stuff to it. You're going to massage it a little bit more. You're going to throw it into a database or send it off to another API or whatever, get the response, massage it a little bit more, and then send it back to the user. That's kind of the general flow for a lot of web APIs. Super, super common, right? But how you write this code is really going to determine how testable the code is. We'll get into that just a bit. 0% unit test code coverage. Whenever you go into a rebuild, you're like, oh, there are no unit tests. I kind of just cringe. I'm like, okay, I know what this code's going to look like. It's going to have some fatty blobs of just like dumped code on you. You're like, oh, okay, here we go. The alternative is 100% unit test code coverage. Is a huge misaligned incentive. Whenever I've worked on a couple open source projects where they've enforced 100% test code coverage, and it is such a nightmare to work in because there's a lot of things that are so hard to cover in unit tests. It's like, all right, my one line code changes here, and then I'm going to spend the next 6 hours writing a unit test to simulate a network failure. It's not going to happen because if that happens, I got bigger problems. This code doesn't matter. Unit tests, you can have really bad unit tests. A bad unit test is going to be really complicated, or it's going to be really slow. It's going to be really flaky. Flaky meaning that if you run it right now and you run it in an hour, or you run it on someone else's computer, you might get a different result. It might have timing stuck in it, and it'll just like fail randomly. And then what ends up happening is people either comment it out, or they skip it, or delete it. Like, this test isn't worth having. Or yeah, so those are your fragile, non-deterministic tests. All right, so I've got just some blobs on the screen here. Depending on how your code looks, will structure how much unit testing you can do. If your code looks like that big green bubble there, where everything's just like dumped into a pile, you're not doing unit tests on it. Because to do that, you've got to mock out your database server, you got to mock out your external service, you've got to formulate an authenticated request coming in. Like, okay, how do I pretend like I'm a user to my code and pass authentication checks and all these other things? Like, that's just hard. That code's gonna be tested with integration tests by some other system, not in my thing, and that's gonna take longer to iterate on. If we split it out a little bit more, pull some components out, you're like, okay, I might be able to mock out my database a little bit and I can test the yellow bubble. Or the third screen, it's like, okay, really split this out into specific stuff. I put all of my really complicated business logic down in this green or yellow box at the bottom there. That's the code I really care about, because that's really complicated stuff. It's merging a bunch of lists and filtering it and doing some calculations or whatever. Like, and the only input is stuff from the database. So if it takes an input and gives me like a number out, like I can unit test the crap out of that. It's gonna be awesome. And then I don't worry about mocking my database or whatever, because database is gonna database. Go unit tests. Raise your hand. No, let's not do that. If you know how to run them, right? Let's go test, right? Go test. It's one command on your CLI. You should know how to run them. Your CI/CDs know how to run them too. We're lazy. Sometimes we forget to run them, and then our CI/CD system comes back and says, "Hey, you didn't run your unit test because it failed." Like, yeah, you're right. And we got built-in code coverage reports. Most important thing is that testing your important code should be really fast and really easy to do. If it's not, take a little bit of time to restructure your code so that you can get that important business critical code and get some test coverage on it. And GoTest is super smart, and it only runs tests when your code changes. So you can see this little test output at the bottom there. It's like, hey, all these tests are cached, nothing changed, you're good to go. I'm not going to waste your time. So the Go people have put a lot of work into making unit testing in Go as fast as possible. So for testing purposes, unit tests can be your fastest tool for iterating on your code. It's not going to be like going to your terminal and sending a curl command to your running server. It's like unit test is the fastest way possible, but only if your code is structured in a way to facilitate that. All our code, most of our code interacts with external things. Got lots of ways to work with that. You got dependency injection, you got mocks, you got the HTTP test package. You can add, when your tests run, you can be like, hey, instead of this function being this, I'm going to make my function a variable, and I'm just going to replace it with this new function just for the test, just so I can cut out some complexity. Flags are environment variables that the test set, so you can bypass code. Don't try to do integration tests and unit tests. It's just not fun. It's like if your unit test is trying to like spin up Docker containers, it's like you're holding it wrong. Sometimes it might be easier to test for things that fail and not things that succeed. You're like, okay, I want to test that these 5 things fail, and I don't know how to get it to pass in my unit test environment, but I at least know it catches these important things. And if your test gets super complicated, take a step back, strategize. One of the coolest things about unit tests is you have a built-in coverage report. Your IDE should support showing this test coverage. So you can just hit your toggle in your IDE saying, show me my code coverage, and it'll show you. So if you're looking at this code right here, this code snippet, like there's an error that could be thrown off of JSON.Marshall. Now you'd have to do something really weird to make that so it does throw an error. So don't try to like fabricate a unit test that's going to cover that marshalling error, because it's probably not worth your time to cover it. Like, yeah, it's fine. If someone does something weird, then Jason should catch that in a PR. HTTP client.do. All of those errors are typically going to be like networking stack related. So like if DNS fails or there's no route to the IP address or whatever, like those are gonna get errors. Those are really hard to catch in unit tests. So maybe don't bother. If you have just code that's like the result of like call function A, call function B, and then call function C and give it A and B, maybe you don't need to test that function because you can just really test function C and make sure it knows how to handle A and B, right? Maybe. Because maybe A and B are really hard to unit test and have a lot of dependencies, and you can skip that. Buzzing is a great tool. Most of us don't have a need for it. If you're writing image codecs, do buzzing. If you're writing like a SIP message parser, you probably need buzzing. Anything with state machines, it's gonna genetically modify your inputs on your tests and just kind of give you weird stuff, and you'll be surprised by what you catch. If you're doing API request reply stuff, it's not going to be helpful. Benchmarking is another thing that's built into Go for performance critical code. If you care about your CPU usage or your memory usage or whatnot, definitely make sure you take advantage of the built-in Go benchmarking. It's just a question you have to ask yourself. Is performance critical on this code that I'm writing? Yes or no? If it is, use it. If it's not, you don't. So conclusion, I'm already a minute over. Ryan's going to give me a hard time about it. Let's broaden our concept of what counts as testing. Let's be strategic in how and what we decide to test. Make sure that we're testing our code and not relying on our customers to test it, because we're the ones getting paid for that, not our customers. They're paying us the money. So it's kind of like a weird inversion. If you're like not testing your code, it's like you need to hold yourself accountable to making sure you're doing your job in a meaningful way. And then testing is not an all or nothing thing. As long as you like making an effort to do your testing is meaningful. It means that you've thought about it. It means that you've analyzed and thought about the risk involved in it, and maybe you decided that it doesn't need to be testing this. It's fine, but at least think about it. Or maybe you decided that like, hey, I'm gonna make sure that it just in my code, I'm like, here's a curl request that you should run against this because it costs a week of time to automate it, and it's just not worth it. So it's just that's better than having nothing. Thank you for listening to my random thoughts on testing and
Good. There we go. Thanks, Jason. First off, sorry for anyone that we missed during the lightning talks at that time, unfortunately. Next is the asymmetry of open source, sustaining growing open source projects, which is given by Matt Holt here. For any of you who don't know, Matt is the creator of Caddy web server, all written in Go.
I think AJ's a fan.
It's great stuff. Yeah, turn it over to you.
Hey, thank you. I'll just kind of hang out by my laptop here. Can you hear me?
Yep.
Okay. It's good to be here. So I confess this is not a Go talk. If you feel gypped or deceived, feel free to get your tomatoes out. But before you throw them at me, I want you to know that everything in this talk I learned by doing Go projects. So hopefully that counts. How many, I love these local events. How many of you are from around here? Pretty much everyone. Who is with Weave specifically? Okay, that's really good. We got a lot of outsiders. And then how many of you are from out of state? No way. Where?
El Paso.
El Paso. Wow. All right. Well, welcome. Welcome to the mountains of Utah. So I think it's great to talk with local groups and visitors as well. So I am excited that you're all here. I want to talk about this problem, this asymmetry in open source. And I said that I gained all this experience from a Go project. You've heard of the Caddy web server, I guess, but this was a picture of our website a couple of years ago, several years ago now, actually. Before V2 was released, everything was butterflies and rainbows, and we were a happy little open source project, right? But actually, under the hood, we were more like this. I kind of love this image. I didn't make this. This came from like a hit piece against the project a few years ago, and I was trying to make it sustainable and figure out how to fund its ongoing development and how to contribute back to the internet community. And some people didn't like it, but I learned a lot about growing open source projects. How many of you participate in open source, to some degree or another? Okay, so maybe half or more. And how many of you maintain an open source project? A few, a handful. Okay, that's awesome. Well, I hope that all of you can get something from this as participants and as maintainers, because there's kind of a problem in open source, and I call it an asymmetry where things are not really balanced, like this poor crab. And so what is the asymmetry of open source, though? And by the way, I apologize. If you were here at Weave a few weeks ago, you probably will fall asleep because I already gave this talk to your company. But this asymmetry in open source is, I would describe it simply as users need open source projects. I think we could agree on that, right? We all use open source projects, and users include companies and organizations too. But open source projects don't need users. And I know you might say, Matt, what are you talking about? Open source without users? That doesn't even count. And you're kind of right, but honestly, the vast majority of open source projects don't really have users other than maybe the author. And even then, they tend to just kind of get abandoned. I don't use more than half of my open source projects anymore, and I don't think anyone else does either. And you can just find that out by looking at the sheer number of repositories that are on GitHub. There's over 330 million repositories on GitHub, and that's growing super fast compared to the number of developers. And interestingly, though, 97% of all companies use open source projects. I think this is actually low. I think it's more close to 100%, and some companies are just in denial or ignorant.
Or they're auto mechanics.
Or they are auto mechanics, but I bet even they use open source projects. So somewhere in the Windows stack of their little like point of sale system, there's an open source project. So I don't know. I want you to think about this real quick. You write some code, you put it on GitHub. Not a big deal. It's just a weekend project. Maybe you update it once in a while. And then two things happen. There's two scenarios here. One is someone uses your code for a school project. And in the other scenario, a hospital deploys your code as part of their emergency room software. So I want you to think about that. And I want to ask you if there's a difference here. Is anything different about these? And I don't know if can we be interactive? Is that okay, Mariah?
I don't care. This is a priority in-person conference. So do it at once.
All right, yeah. So raise your hand or shout it out if you think there's a difference, and if so, what is it? Or if there's not a difference, why not? Just curious what your thoughts are. Yeah.
Starts with if your license covers liability.
Okay, license covering liability. That's a good point. Hospital, that's a little scary, right? And I say hospital here, but it could be like a large organization like Wikipedia. It could be the Panama Canal. It could be a Fortune 500. But yeah, liability. What else?
Consequences?
Consequences? What do you mean by that?
You don't want someone to die.
You don't want someone to die. Exactly.
It's probably not gonna die.
And I mean, there's a whole big question if, are you responsible? Like, are you party to that, right? If something happens, so liability. Yeah, what else, Nick?
I think intention, was I intending for the system to be used this way? Did I account for that? How I built it?
Right. So your intention as a developer. So now it's back to on this side of the authoring of it, huh?
Revenue. Hospital makes money off the things they do. It's not gonna get paid off that project unless it's a really good project.
Yeah, that's okay. Hospitals make a ton of money. We just got our hospital bill for an hour in the ER. It is ridiculous. So yeah, anyway, I want you to this has happened to me, by the way, these scenarios. And so this is a real thing, but there is a difference, I think. And maybe there's not, but we'll talk about that. I think both answers are right because it could be a difference to you if you, depending on how you attach yourself to things and what your intentions are, or and so let's look at this here. So as projects have more users, they become less sustainable just inherently. I think we can see this from our own experience. If a project has no users, it's infinitely sustainable. And if it has users, like infinite users, everyone on planet Earth is using it, it's unsustainable. And so we could ask ourselves, well, why is that true? We'll look at that. And then how do we turn this growing user base into resources and assets? How do we make a community out of it? The project unsustainable in the first place? Why does having more users make it unsustainable? Like in theory, in a vacuum, people could download your code and like everyone on planet Earth could do that and it doesn't change you or the project, right? Well, it kind of does as like natural side effects start to happen where people open issues and make contributions because they want to give back and you have to now do code review. And then, or they ask questions and ask for help. And then you get kind of stressed and you start to lose motivation as your backlog grows and then you get burned out. Can anyone relate to this? Doesn't have to be open source. Yeah, chuckles, laughing. Yep. Okay, so I think the sustainability problem really is not about large user bases because again, in theory, it doesn't matter if people download your code. It's that they go unchecked. There's not a checks and balance. There's an asymmetry. There's kind of a gap created by open source licenses that when there's not boundaries put in place. So open source licenses are great. Someone talked about liability. They do cover some of the really important points where we developers can't be sued. Well, you can't hopefully win a lawsuit against an open source developer because of the no liability clause. And also, we don't want to have to deal with warranties. So there's an as-is clause in open source licenses. And also, we kind of want credit for our work, right? Like it's nice to just, copyright so-and-so or that you helped contribute to this other project or product. Well, we also, some of us want to kind of improve our code and make our project better based on how it's being used. But open source licenses don't actually grant this to us, don't grant us this privilege because anyone can just take it and use it and redistribute it. Well, there's a few other things that open source licenses don't really account for that we developers like, and that is to eat food and have a place to sleep and pay our bills and not go to jail. And open source licenses do not help us here, unfortunately, because all our software is free of charge. Licenses are really good at telling companies and users what they can and can't do. And open source licenses in particular are really good at the can part, but they kind of fail on the can't part, or maybe shouldn't. So we can't really change open source licenses, and that's not necessarily a bad thing, but if we can leverage them to help solve this sustainability problem. A lot of licenses will have this as-is clause, and this should make companies nervous because this means that they are completely on their own. There's no safety net. There's no recourse if something goes wrong. they have to put a plea out to a community forum or find some random post on Reddit that probably went unanswered 4 years ago. And this should make them nervous, but maybe a responsible company would take some initiative to kind of own, kind of like Jason just talked about in his last talk with Tess. Own your code base, own your problems, and we'll talk about this here. Developers, so we maintainers, can help encourage this or promote this by setting boundaries. And if you talk to any decent therapist, you'll know that boundaries seriously is essential for like any healthy functional relationship. And liberal licenses don't really set boundaries for us, which is great. I love the freedom of them, but we just need to learn how to set boundaries. And I think actually both parties can set boundaries. And once you set boundaries, you start to have checks and balances in your system and in your community that begin to kind of rebalance things. So I'm actually going to suggest that open source projects can be sustainable, but it just requires leadership from companies and maintainers to set boundaries, own their code bases and their problems, and work out these relationships together. So here are some examples of some healthy boundaries that companies might set. These are, I think, responsible things. I think this kind of shows leadership and initiative in your organization. This is a little wordy, but you can get it on my website too. But you'll notice a theme, though, is that a lot of these are about just kind of, again, being aware of what technology you're relying on and not expecting other people to fix it for you. So going down your dependency tree, owning your own requirements and standards, not using projects that aren't a good fit. And if they aren't a good fit, you either don't use them or you invest in making them a good fit for you. Why would you deploy software that is part of your organization that you can't support and don't have support for? You would never do that, right? Like you would never deploy code that you didn't test, right? I know we all do it, but I'm just saying that maybe we shouldn't. So maintainers, you can also set boundaries as a maintainer, and I think we talk about this a little less often. Businesses are used to business relationships, but maintainers, sometimes we forget about ourselves, and we love to people please, or we love to, I don't know, we kind of forget what our limits are. So these are some boundaries that I kind of thought of that you could use as an example. For example, you can reject changes. So if someone submits a pull request, it's okay to close it or ignore it. Donations, someone pays you some money, that's not a contract. It's okay. Someone can just give you a thank you, give you the warm fuzzies. And honestly, you don't even have to accept donations. Too much pressure? No problem. It's okay to not accept donations. You can let users help each other. I just can't keep up anymore in the Caddy forum. I used to be able to read every single thread that came in. I can't do that anymore. And so I rely on the community to help each other. And so actually, a boundary that I set early on is that I don't give support for free in private. And I'm starting to get to a point where I can't really afford to do that in public either very often, especially to companies at least. So I'll help individuals, but I favor locals just because it's more fun that way. But yeah, like I don't give help in private to companies. Don't do that. I mean, you can, but why would you do that? Because you're not even helping like the broader community, and you're just giving a company proprietary knowledge for free. Like I would charge for that. You can take your time getting around to issues and pull requests, especially those that you're not being paid for. So there's lots of boundaries you can set for yourself to kind of help encourage an equal footing in open source. Now, one question, of course, that you might come back to is, well, I still need to eat, sleep, and pay the bills. So where do I get the money for that? Because the software is free. And I mean, true. Some time ago, a few weeks ago, someone sat down next to me and asked me what I do for work, and I told them I sell free software. And a discussion ensued, and that led to this talk. So, I mean, yeah, where do you get the money? Well, that kind of depends on who your market is. So if there's three, I don't know, there's probably more than three main sectors, but I like to think of three sectors here for simplicity. You have consumers, you have businesses, and you have investors. Investors in open source is kind of rare. That's also very stressful, and I'm not going to go into that right now. That's a great topic for another day, but consumers and businesses are typically going to be your market for raising funds for your project. Now, if you choose consumers, and if that just happens to be your huge market, I would just let you know that might be a lot of work. Most consumers don't know what open source is, and they don't know how to use it. And they're probably used to paying pocket change per month. You know, think of like streaming services, which are, gosh, now they're like $15 a month. But a few months ago, they were like $5 a month. And that's kind of what they're used to paying. Backup services, $5, $6, $7 a month. You will probably need thousands of consumers as your customers. So if you do go that route, I would encourage you to focus maybe on the enthusiasts and the kind of the techie side of the market, or prosumers, so to speak. And you can price your things boldly. We'll talk about things here in a minute, but build up some hype. So you can do mailing lists, marketing stuff. It's just going to take more of your time. So consumers, you're just going to be potentially devoting a lot of time. I read that there's a 3D printing project that was looking for funding here just the other day. I saw, and I'm not into the 3D printing world, but I mean, I'm sure they have a bajillion consumer users and probably several business users too. And it's just, you have to like figure out where you're going to get most of your money. I mean, you can go on Patreon and get sponsors for $5 a month, or you can get a couple of businesses that pay $1,000 a month. So think about that. They have money and they pay money. That's kind of their gig. So I'm going to mostly focus on businesses because I think that's a lot easier to manage. And I think that will have the greatest change in this short amount of time for open source ecosystems. When you're selling software to businesses, I've learned that company size matters a lot more than how much they use your software or rely on it. And once they do purchase, they're usually pretty committed. They're not usually going to put something in production and then take it out a month or two later. You might have to kind of work with them to get past the experimental phase, or that we're trialing it out. Once you get past that though, and they commit, they're usually in because they don't want to touch it once it's there. And also, when you're working with businesses, it's really easy. I was talking to the ArcClone developers, and awesome project. And one of my top pieces of feedback initially was raise your prices. Like, this is not a flea market. You are the world expert on this really valuable software, this really valuable project. And I think all projects are valuable, by the way. It just depends who is using them and what they're using it for. But definitely, consider that when you set your pricing. No one knows your software better than you, and businesses will pay for that world expertise. So here's a few ideas. And I mean, you can ask me later. I've tried a few things, most of which are unpopular, like dual licensing or various like add-on services and stuff. And honestly, the things that worked best for me are here in bold, but sponsorships and support and custom development work, you can do it. There's a ton of these things though that you can charge for. And I don't know if you know Filippo Valsorda. He's the Go crypto guy. He's really good. He's an open source maintainer, basically, just kind of so he has some good ideas as well. So I'll let you look at this list, and I'll talk about a few specifics here. I'm going to skip merchandise because it's fun, but you get the idea. Private support though. So again, I would avoid free help in private. It just takes up so much time and doesn't serve other people. So don't do that for free. And this can look like emails, calls, chats. You can even go on site. And like I said, you might have to kind of help work with a company until they commit, but definitely don't troubleshoot their things for free. And you could give presentations. If you are the world expert on your software, then there are corporate trainings, there's presentations, there's books you could write. You want to help people become experts in your software as well, and who better to learn from than you? And so let's see here, hosted version. Sorry, I have to go through this quick because this is like a condensed version of the one I gave earlier. A hosted version. So this is the definition of a SaaS, obviously. You can host a version of your software for your clients and totally charge a premium. Some companies will do the opposite, where a SaaS will charge a premium for like an on-site version, which is kind of interesting. Both are needed depending on the company's needs. So just keep that in mind. Discourse makes, I'm sure, a ton of money. And Grafana they do very well with hosted versions of their free software. You can also do development work about your project. So if clients need some custom work done, you can charge for that. I typically recommend not charging hourly just because that is stressful and can easily become problematic once you know, you know. But I always am pessimistic too. So what I'll do is I'll bill stuff like weekly or monthly, typically, or per project. And I'm always kind of pessimistic with my delivery deadlines, and then I end up satisfying customers because I deliver early, so to speak. Now, if a company wants you to do any of these things, and there's probably others, I would charge a premium for these. NDAs, depending on how invasive they are, like there's a standard like don't share our secret keys or something, like, okay. But NDAs, like you're not even allowed to say that you did work with us, like that's like huge opportunity costs. And I would definitely charge a premium for signing an NDA like that. A couple other things. I know Jason just talked about we should always ship tests with our code, but you could totally charge for it. Seriously, they take a lot of time. Sometimes they take a lot more time than the actual code, right? So consider that. And let's see if they need rush delivery. Oh, a proprietary license. So if they're not going to open source their code that you're writing for them, I usually I offer like a 75 to 90% discount for open source work. So that's like serious value for a company. If you're writing code that only they can use and you can't even have the rights to it, you should charge for that. On call, that's like a second job. You have to be woken up in the middle of the night sometimes, so charge like it's a second job. Anyway, there's all these sorts of ideas here, and just kind of depends on what companies require. But I think the most productive way to fund most projects is probably sponsorships. And this has gained some traction, thankfully, because GitHub has recently integrated support for this. But sponsorships are, in my definition, they're subscription. They're not a one-time donation. These are tangible products. So you could remember the old days of going to Staples and buying like the new version of Microsoft Office in a box? It's kind of like that. And so this is not don't think of this as a donation system as you set this up and pursue this. These are products you're offering basically. And so I'm going to talk about this here for just a few minutes as I wrap up. But when you set sponsorship tiers, make sure to consider who your market is and what they need. So I have 4 sets of tiers actually, and 2 tiers in each set. I've got sets for individuals. So just kind of your random person, it's cheap, $25 a month. As kind of a thank you, you get access to some specialized training material I wrote. But then if you're like a professional individual, it's like $50 a month, and then I can answer an occasional email, basically. And I have tiers for startups, established businesses, and enterprises. And then you can offer support as a perk. So a lot of companies that ask for a support contract offer them a sponsorship. Sponsorships are great too, because the perks go both ways. They get more than just support. You can feature them on your website. You can interview them. You can give them some publicity, give them something to show off. This is great for their portfolio too. I would call sponsorship software insurance, but I can't because that's not legally allowed. But they are assurance that you will continue to maintain the project and support it. And so you can think of it like that. And companies will pay for this peace of mind. But I do really want to move our industry beyond this notion that sponsorships are donations, and that sponsoring open source is out of the kindness of your heart. That's good. I don't want to discourage it, but I want to take it the next step now and let's establish some business relationships. If we're serious about funding our open source projects, then let's get the assurance that businesses need. And so what I would recommend here is to get your project in as many places as you can. I experimented with weird licensing stuff, and now you see projects that switch, they've actually adjusted their licensing, so it's not an open source license anymore, or it's arguably open source, but and that's fine, obviously, and it's totally understandable, but it does make things a little harder when it comes to companies getting the approval from their legal teams, because now there's this weird license they need to figure out, or people just hate you if you just do a dual licensing thing and make it confusing. And so get rid of all that. I would recommend get rid of all that and just stick with the mainstream licenses, build up your sponsorships and your community. And most sponsors will probably just want you to keep doing what you're doing and maybe be there for them if they email you or something. So that's the gist of my talk. That was very fast, sorry. But thank you for listening, and I want to remind you that your company can be a leader by sponsoring, for example, the Caddy project. We would love to be an example for the rest of the open source community as we demonstrate how these principles work and how companies can bolster up their products and also support the open source ecosystem. So if you want to be involved in that, let me know. And I say go be awesome because, well, it's a pun. But go and be awesome. So thank you.
Break.
I'll take the stairs. You're good. You're good. We have a break now, so you have half an hour. Go get a snack. Go to the bathroom. Todd, raise your hand though. Todd just started a meetup about hacking, and he wants people to hack on open source projects specifically. So if you resonated with that, go to Todd's meetup. But go get a drink and a snack. You're free. See you in half an hour. We'll start at 3:30. Don't forget, we have a panel after the break. Have a talk and we have our raffle. And so don't enough. Just go take a break and come back.
Playing it. I'm just saying. Trying to get
project is the
like there's some kind of project. Project, whatever you want to be a project. If you need like a passion night stuff. All things considered. From 6 to 10, I'm there. Whenever you want. Just as start shop. He's worth every penny. If I get some stuff,
And 15 seconds later, you can log out. Give 5 times.
Examples. Screenshots.
Oh, that one was where it's just like, oh, here's the thing that I like about they were here's you were coming into that. I had my sites going on.
Right here is what they are.
Yeah, this is like, which one? Like,
John.
See how I just shout out? Just do that.
That's kind of what Spencer said. I was like, I'm sorry. To your well. You point out tell us files. So these files will send. Yeah. Once you turn off auto discovery, you don't get you need to. Sure. Same way you include other files. So you can just do it what they
if you have to sell them.
that might depend on the individual. Do not rename it, yeah. Or docs right.
Just
skill based, like if you're like winning in Vegas.
we also bring a lot of people that are like, I don't think it's.
Check the docs.
Tell me what you want.
You know, disingenuous. I guess we could turn something on here that's heading that said,
those are
we could like, okay, you can do these, and then one you can say also include. I didn't want to design. We didn't want to say like, here are the files you should send. At least send these, and then.
Offline loves that.
You just check, be like, okay, you told us to send these. Maybe take it out of the backpack. I want to take that because turn that on.
I just started.
We're all in one room. We're not moving around. So you don't have to dedicate it. They are. I do actually. But you have the time to.
It's a new one like that. I'm sort of a little bit shocked.
Just do everything. That's right. Just for like, that's just.
The final state. I have no idea. Same one, but like.
Unique. Switch all to HTML.
Yes. I had to go in to each of the classes right now. Fix. They have a web. This is now instead of backticks, having it in code, which is the only thing that I found release by just going to the internal website. The other thing is all the web APIs, making sure that header that combines all your list starts. And it really should be the it's fine. As long as when you're writing it, you can head out and you're the post. This website.
It's not the word. It's not, you can see it's a less. It's more like verbose. Right? There's all crazy like you're writing. It's not like you're with my computer convert docs that you just looked at tape. And you write that in HTML.
I go to the website. Oh yeah, there it is. Yes, exactly.
Coded responsive.
I'm a farmer.
Cool.
What is pieces of generic? Currently, haven't, as well. Yeah, I've like.
That is true.
Oh, the little pad, little sample pad. Is that what you use for your, padding under your desk? Oh, that's a good idea.
What up you talk?
I have a couple.
That's what you really carry around.
They're like.
That's all you need. This is I was talking to him because I told him I bring it to work. Yeah.
You should 3D for it.
I'm gonna get like a case.
Oh, there you go.
It's just doing that free back.
That's all I need. Solid. And you know what? If I'm a little rough on it, because it's not in a nice case.
True.
Yeah. Yeah. She brought me to be. I was there for a while. You're there a long time.
I have one that you can actually borrow. Like a month or whatever.
Yeah.
And radioactive.
But I was also so safe.
Have like an insurance come in and think about it.
Yeah,
so they get experts. And then the weapons broker charge about insurance company. It's radioactive. It's set for making sure that they like just it's been like a year of my layers. I have my left leg switching buttons. Right. Like 7. At that point, you're just like, what can I do? Everybody knows it's like, what was this?
Just like you have a lot.
All the logic of so
one of those are
run only is radioactive.
One trillion.
Everybody got something like this.
You advertise
It does look like a super.
Because the accelerator.
That's how I heard about it.
It's not as
I
good.
heard about that. That's not why
So look at.
I was involved in it.
I was thinking I will spend the time to adjust.
But it also.
Miss Emily.
Like all these things.
Comments in there, you know what I mean? Like that's so great. Like that's the thing I've seen change how good stuff. I thought that was fun. So I started.
Oh my gosh.
Sorry. I want to be like I go to enormous place. Oh, there's no normal. All the things. This is just not. No, he actually is not. He's like separate. Home row is that's not bad. Using it means that when your goes up, you're not W. Well, it's not or they're not right. I have this. I just have to. Yeah, it means that like if I want to play a game, that's like my hand. Oh yeah, I need to share them. I thought you was mine. I don't know. Hotel. Everybody puts back to said. One of it was great. Love it. Even show. Yeah. I would say one. I also have one. I did great. Promise me one. No. Well, honestly, I learned dreams flickering. No. So you double like 8 oh my gosh. Back today. Not already with so many things. So cool. Mac, and I heard you guys talking and I have like a yeah, no, I should definitely do it because I give them they got like stretching weird. They just like that tense into sort of stuff. Like how much it's pretty cool. I've got this little like over here. So okay, here's my theory, right? I have no idea either. That's what got me started. It's really actually just like reading. I guess the only had to run like a but then you get a different so like really it would be nice as a compliment. 30 print has that. Yeah, it's like literally a rectangle, but it's like straight that has traffic. And then I was like, it was like a nice like I might have got this up wrong. I think the sounding is repetitive. The other prices I saw it was like well, it's like the input output. I saw was like and I was like, Cypress sucks, but they use this from like yeah, we just do this in a terminal. I love hot damn. On that version. That's always very. Oh god. I love it. Oh my first 300 years. Starting on something. I mean, I have the reach far enough along that I need enough where I just walk up.
something I get easy.
Otherwise I wouldn't.
And it's also never kind of. I mean, it's kind of nice not having to be like this because once you do that, I don't know. It's
Stuff I write like
yeah. So I can start like just right. I'm like, wait, now what am I trying to do?
like who I learned
Your economics is like what's under it. I feel so. Oh, right. So it's like this. And the whole is like this. Like this.
scholarship. So you're and then you
I gotta go grab some.
Oh, dang. Okay. That's electrical. Like trying to link the certain. Just to, I can't remember. Whatever it's called. Like you don't get you don't need to use a relative. Part one always type 15. What's that mean? It might be like it's not. All right.
Oh my god, my center has like
Even necessarily complicated, but you gotta think of like the one I use. Mostly about the brand. The problem that this schedule is very symmetrical and like it allows you to visit a function earn a thing. And then it's search for spin air. I love it. You don't have to use for this. I kept in bar blah blah as this type. Just have a function with a closure around that where use it allows you to just say like the results. Spinner while the work's happening and return the results up. It's not. It's one of the rare cases where it's cleaned up some code. I wish I knew this. I'm curious what he's going to results. It's not necessary. You've got the motors to go to cars now. For a long time, I've been wanting to wrap the spinner because that's sort of. I remember stuff. What do you mean there's no operating system? Wait, you guys want to use it? Yeah, I did the same thing. I did all this. Like how it's I or this is time. Oh, okay. I'm very easy to pick my so which I do almost every day. Share plays. Flag or station. Like understanding it's so funny. Really? I'm not surprised on that. Like stuff like that. I don't need to go super. It's I want to go how like you have to get almost like we might want to make the default. That's like it turns out to be really nice to see just how long it really took. When you're saying it's spinning forever and you say it took 3 seconds, realizing it actually took 12. We want to just make a I did my talk in the room.
Okay, so it's like sorry, that's what I'll say like that.
It's like anything like slide on the thought it was great.
Because
It's very much like you build up like slow, the ball really is. And so as soon as you change in the data source.
and Victoria trains. Because now the course. I did yeah, something I Victoria.
Yeah, and you'll have to.
That's pretty good.
Oh, okay.
I'd rather have that feature and.
Yes. Yeah, you know, sort of go back to the.
Nowadays. Well worth the space.
There's still case for us, like, yeah, like understanding that you like understand where you're building.
I didn't think it was like and then earlier stars.
Have so much more.
I'm just.
So they last few years starting to try to come up with
the place I
for a long time, but like. And so you also actually know what that means. You can imagine. Hey,
they were always like, oh, there's 300 miles or whatever.
Bug is like, oh,
sure. Starting to support that. They so much. Certainly, we're starting to see. We're like, we have an SLO and like, we have never said that we would guarantee X, Y, or Z. How of they're starting to like try. Survive this. We can't like we don't know what happened to infrastructure without having for
so you could be like the founder of said
so I if you don't define an SLO, something just start
that's exactly you don't define your path.
In the side.
There is like you can actually do placement. If you really have an application that is late to run on saying like
that's not
so it still doesn't guarantee.
So those mountains
don't usually fail. The same problem is that we have to account for, oh, you had a bigger problem earlier. We're going to buy flex rate and how we sell it into another one. Like, it's going to have like the lower bounds of like that is a little still achieve that.
There's someone with a fancy hat.
No, that's not happening all the time.
That sounds pretty good.
Yes.
Have you ever seen the Browns? Snapshot of your memory because any box across the wire as it can. It's tracking things that's still and at some point it has to like stabilize it and actually send over the meeting. But there are certain like applications that deliver that things and they see that brown out. instead the flag that says, hey, if I need to put me down.
So you have like
I don't have them in the physical world.
I realized. Yeah, that one.
Not really physical, just a cloudy cloud.
More, it seems almost more expensive because like you're paying for all of the visualization features instead of like actual storage or the actual network. Mostly because of the portrait.
similar to
This is stuff. I think they're inside the same space. End up being have they're in the same zone. They might actually be in different cells of that.
Yeah.
Okay, but you're a lot more than
a lot more than 0.5. If you fix those, so
I'm really I would for a magnitude
there's a big town where so like servers all over. It seems
it's not hard.
Lose tens of millions of dollars.
It's not winning the lottery. We see that there's quite a bit online.
Design your application doesn't require hundreds of thousands of
but I really like
literally giving my word restricting you.
Good to get the point is that the doctors when they've been for 6 years like they need to get their eyes
Guys,
good.
yeah. Another panel discussion.
You know.
I know. Please do. I'm waiting for the third. All right.
You do all the talking.
Okay, this probably is going to be one of the shortest panel discussions of ours. You know why?
Why?
We're at a Go conference. Why would there be any errors? Right? I mean, why would you have to handle any errors? Go is just incredible. And let me rephrase it. Does anyone actually write errors? Come on. No.
Wait, didn't you see my code? This never mind.
Yeah. Anyways, today we're going to talk about some of the best things you need to be aware of with error handling and Go. I'm looking forward to hearing this because there's some people that I know that know these things. In fact, we had some interesting tidbits just in the lightning talk with the interfaces. So we'll get into that a little bit. But first of all, let's just start out with why do I care? Why do I care about errors in Go?
They're gonna happen.
Okay, they're gonna happen. Okay, Carson knows they're gonna happen.
To the mic, Carson.
I'm sorry, because they're going to happen.
Turn it on.
Oh.
Wait, error, and we are gonna handle it right now.
Really drill this in. We care about errors because errors are going to happen.
What is going to happen?
Also, all of the time, technically, at any point,
You just
right?
don't know,
Yeah.
right? That's the key with errors. You don't know. Now, some you can plan, some you can't. So let's just talk about it. I'm gonna ask. I always love this. Who loved the job? Who loves? I said it in the past, which is really past for me now. Who loves the Java way of error handling? What do you do? What's the Java thing?
Exceptions.
You punt, right? You just kick it up, right? And then you just that huge thing, right? That's the Java way. Come over from Java, .NET, some of these other languages, and you go into GoLand, you're going, oh, this is kind of a growth way of doing it. I wish I had that way of throwing it up, right? So, first question. What's the best way to handle errors in Go? And why is it so, at first, feels so weird?
I'll start to the mic. We handle errors by receiving them when they happen, right? Well, in two ways. There are panics. Panics still happen. There's still defers that you can sort of emulate trying to catch. But we actually receive our errors as data for errors that are common, right? And we don't, I don't know. My first point I want to get on this is we handle it that way because in Go, we are programming defensively. My biggest problem with try and accept, and or catch, whatever you want to call it, is that it's optimistic coding. It's just assume everything's going to be fine. And what it leads to is you missing out on catching kind of halfway states. So my biggest beef with it is you're like, well, just throw it up. And like, then you really don't have to think about what if I'm halfway through, I write a file and I'm going to write 2 files and then the second one fails and I leave some garbage around. Try catch you don't even have to think about, right? Go, you at least have a place where you go, I'm about to return here and I'm looking at the function. I just did one thing. Like if you do try and catch, you start to think everything is just sort of like a transaction and it's not. So by getting those errors, you have to think about them all the time.
Errors are values, and so you can check them and you can check for the error right where it occurs. And it makes it so that you can proliferate that back up in the stack and find where there.
Okay. I say is that if you do the other languages, you have to have if else's on that. Do I know this is true or not? And so you just say, if error is one of the return values, you could say, did an error happen early? And then you don't ever have to have else in your code because you could just say, an error happened, return, and then do the happy path for us. So with returning errors as you go, you have all happy path code on the left. And you don't have to have 12 indentation. Do try catch, or if this, if that, because it's all happy path once you've handled the errors beforehand.
Okay, so what we've heard is Go is
happy.
The happy path. We're happy. We're happy because we just go. Okay, I like that. So let's have some honesty here. First time you saw Go, programmed in it, and you had to deal with errors. What did you think? Did you like it? Huh? Come on.
Absolutely not.
Okay, absolutely not. Thank you for your honesty. Others?
Loved it. I knew exactly where failures might occur.
Loved it, but kind of, okay. You knew exactly what's happening.
I didn't know any better because Go's my.
You didn't know any better. That's the Go way. It's the happy way. God.
Uh-oh.
It was better than C.
Well, okay.
It was ugly and verbose.
Ugly and verbose.
Every time I hit a function, I had to handle an error.
You had to do something. I mean, you actually had to know what was going on. Yeah, and that's what I found. Okay, so you mentioned it. Let's talk about panic. Who likes to put panic in their code and why? AJ?
I like to put panic in my code because it's code that should never be reached. And if it is reached, it should panic.
Okay. What do you think?
Yeah, I agree. There is a time and a place absolutely for panic and recovery.
Where's the time and the place?
When exceptional things happen, you can basically emulate the exception model, right? There are places where you say, like, if we get to here, everything is so far beyond saving that I would rather just exit the entire program potentially than try to recover.
There are differences?
Yeah, I agree. We had a case where we were wrapping a database update in a transaction. And if there was a panic, we would try and recover and roll back. But if the rollback failed, we'd have the panic.
Okay.
So it would be better in that case to terminate than continue with bad data.
Be done. Okay. Jason?
I heard but somebody wants to tell me the only time you panic is if somebody else already panicked on the code and you can't read what their panic is, and so you panic to make it more verbose. So you recover and then tell what the panic is actually doing for your code, and then pass it from there.
That's truly a panic attack.
Don't need to.
Okay.
Most
All
of the
right.
time you don't.
We had a comment.
Panic is great too when not just because like you don't want to continue, But when continuing would risk loss of data or damaging hardware in a really horrible sense, something where it's like, it's really better to just stop than to do anything else because you might break something that you can't recover from.
So it's better to be dead than just to kind of, right?
Well,
Okay. It's Halloween, so I'm just thinking about it. Take others with you? Okay. No, I don't know about that.
I typically don't write too many panics in my code, but I heard as I was learning Go and some patterns that I was looking at, like the idea that there are certain functions that if, like, you know, in the startup of a service or something else, where if they do not succeed, you will be continuing in a state that's just not clean in the first place. Like a lot of times you would, you know, preference some of those methods with like the word must or something. The idea that this must happen, and if it doesn't, then you would be
okay.
Yeah, kind of in the testing scenario, it's the fatal, it's the T-dot fatal. Like it's not worth going on. If this thing didn't succeed, just kill it, and we will be made aware.
So interesting pattern, perhaps, right? If we're testing code, which we should, whenever we think of that fatal, is that kind of the use case for a panic like that? It's kind of an interesting pattern. Frank.
Yeah, so this is just more of a general question again around panics. When I've encountered panics, as I've been trying to do code, it shows that I don't really know how to use the reflect package very well. But
that's okay, Frank. I'm just letting you know. Okay, it's okay.
But like that kind of feels like a totally different thing than saying, hey, it's not worth continuing on. I mean, maybe it does, but that feels like there's something. I mean, clearly you have to test your code and get that sorted out. But
I think that's one of the cool things about the defer recover thing is someone called them you want to poke recover refer, one to catch them all. So in your main, you want to have a Pokemon panic refer recover on the top. So that way, if you ever do have a panic in your code, you could actually log it out correctly and you'll catch it somewhere rather than just crashing your application. So if you catch it somewhere and then you log it right, then you'll be able to fix it later, as opposed to just your application being weird and not knowing what happened.
So now I know why they call it Pokemon Go. Chat.
That was funny. What I've learned from reading the standard library when they panic is that I see panics where it's a programmer mistake. If you can guarantee it's like a programmer's mistake, that's usually where I'll panic. It's very rare, but that's where I'll put a panic. And if it's an input or an external like IO thing or something, an error, then just normal handling. But if it's strictly a programmer's mistake, they did not read the documentation, they're violating this, like we spelled out very clear or something, then it should definitely be a panic in my opinion.
So the pattern principle is I use a panic when I feel really guilty as a programmer. But I want to ask you a quick question on that, and then we'll get right here. You said libraries. How many love having a panic in a library that you don't know there's a panic in?
If, like I said, if I really messed up not using the library, getting a panic right away can be really helpful.
But does everyone scan the library code to see if there are any panics to know if that landmine is going to be there?
Yeah, obviously have to be additional.
Huh?
You should recover liberally panic sparingly.
Oh, in that space. Okay. All right. Sorry. Please.
I was going to expand on that where most of the time I feel like if I use panic is in lieu of the compiler. So the compiler didn't check my regex that I didn't check my template that I parsed. So I'm panicking because I want to know about those things
because something happened. Okay.
Whatever sake.
Any follow-up kind of comments?
I was going to add, yeah, I totally agree with that. Like the must comes and the programmer error, like the canonical examples of this are must compile regex, must compile, must load template, like things that like we're going to do this once when we start the program. These are going to be critical things we're going to use a lot in the program. And I don't even want to start the server if this regular expression that I've heard, you know, it's different when you're doing it as part of an input. But if you're just setting it as a variable at the top or loading it once, like, yeah, panic. Just say like, I can't, this isn't regular expression. Instead of failing when you try to use it, I'm going to fail really early on.
Okay. I'm going to ask a question then. So I had a good friend that when he would use a panic, it was very similar. And he would do it in the startup if I couldn't get a connection to the database. If I can't do anything with the database, why continue? Good pattern or not? Clint's going like, sure. Okay.
We try to reserve panics only for application setup. So I need to talk to SQS. I need to talk to my database. I need to make sure this file's there, right? If that's not there, I need to explode, right? And I need to alert the whole world. I think basically everything else is pretty much recoverable unless you're working with, hardware or anything weird like that. But I think for the most part, you can be recoverable basically everywhere else.
So if you're Kubernetes people, then there really should be alerts on crash loop backoffs. Is that what we're thinking? They actually mean something.
It's interesting because I feel like at the same time at the startup is like almost where you're the least deep in your code, and that's the easiest place to just log.fatal or just an OS exit and save the panic for where I don't know. I don't write a lot of panics, but I run into them because panic's a good way of the code letting me know that there is a path that was executed that I as a developer probably didn't account for.
I say agree with that completely. I don't write panics into my code for things that are expected. And so a database being down is a log.fatal. It is not a panic to me because that's an expected path. The database can be down. And so even the main, I only have fatals in the main function before setting up. And then panics are always just things that are completely unexpected.
All right, enough on the panic. But some really good tidbits here and probably some things to be thinking about in your own use cases and maybe your own patterns that you want to establish. Let's touch on, Carson talked about in the lightning talk, hey, here's package, interface. How do I kind of make errors good for me? Yeah, how do I give them value? How do I make them meaningful? And let's go across.
So I have a package I use for everything. I call it context error. And what it does is it lets you add fields to context, and then it's just a map of string any. And then when you have an error, you get all those fields back out. And so since most of our logs are JSON anyway, things like user IDs and like location and stuff, I don't want that in a giant message in my log, but I want that available for when I have an error. So I put those all in the JSON instead of having them as part of the message. So my logs are readable and I search for things without having to just giant 25 line just message. So I use like errors in interface to be able to pass in to a struct that I turn back to the JSON mesh.
Okay.
For the most part, we use some really cool tooling here, I believe.
Yep.
Called W error.
Yep.
But I did find in some of our services that we do use the just error kind of native package error is to check for something that may not be considered an error. Like if you are, okay, for example, we do a transaction in the database. If it fails, we're rolling back. And as we roll back, if a record was never created and we try and delete it from the database, it's not going to exist. So to check for no rows, like SQL no rows, as part of your error, and then you can move on confidently, because if you're trying to remove something that was never created, then that's okay, and we can continue.
So the error is and error has, no, as. No, two different ways of looking at it.
I have one last thing to add, and this is something. So I got back from talking about interfaces, and Brandon's like, so you take structs and you return interfaces. Or sorry, you take interfaces and you return structs, right? You take interface, return like concrete types. And I said, And he said, what about error? Here's an interface. You return it all the time. And my brain broke for a second because I'm like, oh, crap. You're right. Like there's this one glaring exception. And he said, should we just be passing instead of returning an error, should we just be passing a struct back as a second item that happens to implement error? So it can be received by all the things that take error as a second argument, but internally within our code, we don't pre-abstract our errors. And I don't know yet. I haven't actually, I'm still in on that.
Okay.
So
Makes sense. Makes sense.
You just think.
What?
Right, go ahead. You had to go.
Is that what you do?
The reason for that is because errors aren't scoped in Go. And so you have an ERR and you can colon equal every time. And so if you return the struct back instead, if somebody tries to do an error.new instead of your special struct and that gets returned, then you're going to have a different type error. And so you have to do errors so that way, because error isn't a different variable every time, unless you want to say this is the special error, this is a special error, this is a special error, and name them every time, then you wouldn't want to do that.
Talk about shadowing, like reusing the error variable.
Yeah, it's reused and shadowed without you even knowing it most of the time.
I was just stewing on that idea.
Please.
Yeah, something I was going to comment on, just the idea of returning your own error. A potential danger with that is if you happen to say, hey, if this returns type error, but you like implicitly change the type from your error to the standard error, when you go, hey, is this nil? It's going to say, nope, it's not nil. Or it's going to say that it's not nil, even though it technically is, because it fails the type check on the is nil.
Yeah,
I ran into that. It took me like 2 days to figure out why nil was not nil.
Brandon has the entire talk on that on the engineering blog. It's really confusing.
Right.
No, he does.
Yeah, it's up and available.
Nil was not nil, but I think it is nil, but we won't. Okay, go ahead. Nil? Please.
I was gonna say, I used to do that, but the reason why I stopped is because I found it for future safety, it causes a problem. It tends to make contracts more fragile. So maybe at this point in time, you're only gonna return one type of error or one error value, but in the future, if that underlying function becomes more complex, now there's 2 error cases. If they don't fit nice in that type, you have to change to the general error interface, and then that breaks the contract.
But just internally in a package for private functions that are broken out. Like, I feel like that might be better.
There's like it depends on the layer of abstraction. If it's an internal tool, that makes sense.
In your package, want to do probably errors.wrap. I mean, like wrap your error every time.
Yeah.
And so if you're wrapping, unless you have your personal package have a wrap function that handles it well, it's a little might be complicated.
But what I tend to find too is in small internal tools where you would pass a error type instead of an error interface that's very specific to that case, you're likely better off just returning a Boolean, because if your function is that small, it's either okay or not okay.
Yeah, I was just gonna ask, because in the, like, I came from C# and it was really quite nice when there was an exception, because the exceptions always had the specific type. You could say, oh, no parameter or set of bounds, or whatever this type of exception. And so if you were calling that, you could expect that, and it became easy to test. And so when I started writing Go, I immediately gravitated towards typing the error and saying, oh, it's this type, it's an error not found. And I would type it because I found myself writing a lot of unit tests that would say, like, if the test should expect an error, does the error message have the right output? Like, I don't know. Maybe that's excessive testing, and I just wanted to get some feedback if people like this.
I mean, like, realistically, our test, the value is that we're doing the right thing and we're getting use case to our users or when implementing our code. I'd say part of good errors is good messaging with that. I don't think it's a bad test. It's really just test.
Yeah.
I think it depends on who the error is for. If you're returning an error to the user, you want to have a kind of if there's something they can do to fix it, you want to give them a message of how to fix it. If there's nothing they can do to fix it, you give them a 500, and then you have a good error. And so you need to, I think, like you said, one of the harder things with Go is that when they created errors, everyone just said return error every time. And eventually we decided that, wrapping your errors every time and giving more context to it as you return it up the chain is important to know. If you wanted your own error that creates a stack trace every time, you should probably do that, but it's better if you decorate your errors as they go up, then you know exactly what happens along the way, rather than just a random.
Anything else?
Can I add to that?
Please.
Yeah, so we actually made a tool for an internal team to join kind of two locations. And there's a lot of configuration and primitives that are created in this process. So we automated it, but errors and wrapping our errors and very explicit messages and tags was huge to identify quickly an issue when this tool was being used. If there was a failure, we could quickly trace where the error was happening, what the misconfiguration was, and make improvements on the model. So that the custom error package, which does a lot of the wrapping for us, is huge.
If you're throwing things up the stack all the way to the top and that's your only error handling, there are not even these touch points to add context along the way, unless everybody try catches everything all the time. And then that's actual code bloat, not just, I don't like to check if my error's not in.
Yeah.
Right? Like having that context makes a big difference.
So I think it'd be very interesting to follow up this kind of discussion, kind of the, maybe I'd use it, how I'd use it, when I'd use it, that kind of this discussion you were talking about before in the Forge Go channel. Let's just jump on to something a little bit similar, but maybe helpful for those that are kind of maybe new to the language. Do you have any, we kind of talked about it, but would you have some specific ways to make error handling look better? You know, we have packages, we have some other things, but sometimes it gets, you know, all the time. Do you have something that's better than that?
No.
Okay, so thank you very much.
Find the way it is. Do not there's a visual there's a visual style to code blocks. And Brandon note, I hate the assert packages. Every assert package that exists makes your tests look visually different when failure states.
He has an opinion. Okay.
I have a massive opinion on the assert packages, and I think there's nothing wrong with the fact that visually we see if error not equal nil. We see it a lot. That repetition isn't a problem. It's clarity and its consistency across code bases, and that's a feature, not a bug.
Everyone agree with him?
Yes. No.
That's okay.
Whoa. You don't have, come on, bring it up.
Oh, me?
Yep.
Oh, I love Testify, sir. That's my favorite.
Well,
that's.
Is that what you meant?
I'm talking about, that's an example of every use case I see for I'm trying to, even when your editors take that if error not equal nil thing and wrap it up into one fake line. Again, visually makes your code harder to look at a glance. My big problem with Testify and assert is you, instead of just doing the normal, all of the equals and the comparisons you do in an if statement to find conditions, you have a billion different bespoke functions for everything you want to check. And you have to say, well, I can't just say if this is equal to that or this is greater. I have to know all this massive corpus of function names to replace if statements, which we already know how to use all the time. Half the people I talk to, do you know the difference how to in assert to do a fatal? Does anybody know? So we can say assert x equal y. How do you do the fatal version of that?
Required.
Yeah, but
Takes a T as the
it's another package with a completely duplicated set of functions that half the people I talk to don't know. They're I don't know, they just do assert everywhere. They don't think about it, right? Sorry. That's
I just to take it back to errors. There's a common pattern you see where people just make a function called handle error.
Yep.
And they hide their if statement inside that function. That's what Carson's saying he doesn't like, because the nesting and the flow of having that if error equals nil condition close takes your eye through the error handling process and makes your brain read it.
I think are we good?
So that's.
Oh, yeah, I just want to add on to that part.
The assert was a side note. Go back to the errors, and I understand his point. I always do if. I don't care either way. I think you have to train yourself to think that way. But I personally also find that if flow makes my brain think harder about handling the errors.
Okay, when you exit, I want you there, and then Carson that way. Go ahead.
Oh, absolutely. No, I just want to add on to that. I think if you're reaching for a handle error function, you should probably enforce cyclomatic complexity on a linter somewhere, and then just reduce your functions to smaller pieces and keep your ifs where they belong.
Yep.
I think you're reaching in the opposite direction.
Yeah, very good comment.
I do have a weird best practice that I think is that you should have nobody does this, but I like having a function called handle that you use throughout your entire application, because there's this thought process of what do I do with an error when I get to the top of the chain? If you get into main, if you get to the top of a defer, if you're inside of a concurrent function, like what do you do with an error? A lot of the people just hit log.println, and it might be log.println, but it might depend on what your team does. And so if like I had a company where we logged it in a specific way, if it's an error, if it was a 400 error, then we made it a warning. And if it was a 500 error, it's an error. And we also did a metric every time an error happened. And so we had just a function called handle that you passed all your errors to at the top of your tree. And then it handled it the same way every time. And you didn't have to, I think anytime you give a developer a choice, you're going to have bugs sometimes. And so you take away that choice of what to do if you give yourself a handle function that is just used at the top every single time.
That's a different point, Carson. He's not saying don't handle errors. He's saying at the end, let's make a path. I think it's a different. I think it's completely separate points.
You're not saying every time.
No, just when you get to the very top of the return, when you can't return.
When you get at the top, you do whatever you want. Yeah.
That handle function is still inside of the if statement.
Exactly.
You're still saying if error is not equal nil. Handle.
If there's no return for error, what do you do?
We've handled this error.
Yeah, that's fine.
There we go.
All right. Well, we're out of time, but give a great applause to the great. Don't write an error.
True.
Awesome. Thank you guys. A round of applause. Next conference, if we have downtime, we could just have Paul do some stand-up.
Hot takes.
All right. So our last talk I'm really looking forward to, it's Nick Lloyd, and he's going to be talking about why Go.
Not sharing your screen.
Yeah, I'm trying to turn it on. I didn't realize.
Chrome makes you re-enable it. Next time, I'll make sure my capture card works. Then it's just a plug in. But this is way better than last year. We didn't have audio break. Right?
Yeah. Yes.
I don't care.
Over to home. Get in there and look around.
You still have an after part, right? There we go. Add to this. Look at that. Okay, sorry. I need to reshare my. Almost there.
All right. Well, we're getting that going. First of all, so excited to be here. This has been just absolutely incredible. I appreciate these things, if not for the sole reason that they remind me that there are always a lot smarter people in the room than myself, and I appreciate that. This presentation is called Why Go. I was given basically the option of choosing my own topic here, and so let me explain a little bit about kind of why I chose this. Oh, first of all, I'm Nick Lloyd. I'm the VP of Engineering at. I chose this topic because in large part previously, because the last time I gave a presentation at the Go meetup, I went really, really deep and nitty gritty on Go's garbage collection system, and I lost the entire audience. Like just super fast. I went way too far. It was really pedantic. I shouldn't have done that. And so I'm trying something new, which is I'm going way high level instead of trying to dive down deep through some big technical issue. So hopefully this works out. We're going to find out if I do a little bit better at maintaining the crowd. So a couple of caveats. I'm talking about why Go, why people are still using Go, why companies are choosing to use Go. But just right off the bat, I'm a believer in using the right tool for the right job. So I'm not advocating that every single possible thing should be built in Go. I don't believe that there's always one right tool. So there are frequently more important factors than code performance architecture when you are choosing to build particularly an MVP, right? When you're building projects from the ground up, choose to do something that you know really well. So another caveat. And then this last one is a caveat on the fact that I am not a designer. My aesthetics are terrible. I do a lot of bullets and blocks of text. I apologize. So how I came to Go. I'm going to start off with like why I use Go, why Route uses Go, and then I will transition a little bit into why other people are using Go. So I learned to program in C and C++ when I was younger. And then, you know, I did a lot of things before coming back to start my career in tech. But when I came back, I went to school for a computer science degree. And, you know, there, I went to the U. If you went to the U, a few years ago, most everybody learned in Java. And then you got thrown into C and C++ for some of the lower level classes. And then I started off my first professional gig in C and C++ and a little bit of x64 because we were doing custom hardware stuff up at Raytheon, which is where I started my career. And I love low level languages, probably just because I learned that way. Anyway, so I moved to working in Python after that, though I could kind of change directions. I went to a fintech company that was using Python in a very interesting way. They were using Python because they wanted something where they could attract coders, younger coders. They'd previously been operating in C, and they wanted something that was a little bit more readable and could attract a different group of engineers. The problem with it was that Python just was not fast enough for their use case, and so they were freezing it, which was a really fun thing to do to Python. Anyway, so I learned Python there. I was working in kind of both Python and C because they were switching out of C. And then I went to another startup pretty quickly where I started there because they were in Python. They were also using Django. I hadn't used a platform on Python previously. And I grew to hate that pretty quickly. I like to have a lot of choices. I like to be able to do things my way and not have things dictated for me. So I decided to do a project for this company that was primarily, again, the back end was when I got there already in Python. I wanted to do a project on a separate system. So this was a real-time notification system that I needed WebSockets to do. I did not want to lash that into the Django monolith that we had because I didn't like Django's implementation of WebSockets, and for scaling reasons that I didn't think that was going to work out very well. So I knew right off the bat I was going to be making a new service for this, and I wanted something that was relatively lightweight. I wanted something that I felt like I could scale really easily, and I knew that we were operating in AWS at the time. I just wanted to be able to scale it horizontally, and you know, I cared about the ease of concurrency because it was a very IO bound workload. And so that mattered to me. Again, I really hated working in Django. I didn't like the limitations that were imposed on me. I didn't like having how I interacted with the database dictated to me. That was a real pain in my butt. And so, you know, I decided that Go was the way to go. When it came to building this project, it addressed these issues for me, and I was already familiar with working in C. I thought so that the syntax here, low level syntax, is good for me. So then what? The project was a success. The Vandy story here is that I left that company pretty quickly after the project was finished. They called me about 5 or 6 months later, and they were like, "Hey, where's that code for that project?" And like even the infrastructure, the Terraform for it and all of that. And because it had just been happily working with no problems in the background for 5-6 months, nobody had to touch it. Pretty pleased about that. But like I said, I left there pretty quickly. I had learned to love growth through building that project. And so I decided, hey, I want to go somewhere where I can continue working and Go. And so I went to a couple of different places and finally ended up at Route. The new CTO who had just come into Route had made the decision that he wanted to build the backend systems in Go, or at least the initial ones. I was his first engineering hire there, and I was really excited about it. I was like, great, this is an opportunity for me to go build a lot of brand new Go code with some people who have done this before. And you know, I had the chance there to build a lot of the base architecture and a lot of the core systems that are still in use today, albeit, as any of the Route engineers here will tell you, heavily modified at this point. Thank goodness for that. So why does Route love Go now? And I'm going to give you my answer first. First of all, you know, like, as I mentioned in reasons that I decided to use it in the first place, I like that it's really lightweight. I love that you can build containers that are like less than 15 megabytes. This matters in a cloud environment because you can stand up, you know, clusters of microservices, and every little bit of memory counts. We're not operating in a system where that memory just becomes more like it doesn't matter over time, because we have changed the size of the tasks that we're doing. And so over time, you can get real cost savings with lightweight services and containers. I like it a lot because it's a really easy to understand concurrency model, which, you know, coming from a C and a C++ background, I understand how to do concurrency in C and C++. It's a hard thing to explain to other people how to get going in. It's a very difficult paradigm in which to understand, like, how to track down errors and things. I think Go solves a lot of those problems in a very elegant way. And a lot of the workload at Route is absolutely based on multi-threading and being able to do concurrent workloads, because we're very queue-fed for a lot of our microservices. You know, one of the things that I also appreciate, and one of the talks was on this, right? Unit testing. As long as you're careful about dependency injection, that's a little bit of an inside joke. I think that the unit testing capability of Go is just absolutely phenomenal. As was previously mentioned, it's right out of the box. There's no, you know, question of like, hey, what am I going to go use? You've got it right there, and it works really well. In my opinion, Go forces easier readability than a lot of other languages do. I was a heavy user of the ternary operator in other languages. I thought it was really cool because I could write these things that like were so concise. And you know, over time, what I realized, as many of you have, is that you know, you can write some really cool things that are very concise and very elegant that nobody's going to understand on first pass the next time it's looked over. That's a real problem in a production environment. It's not a problem if you're writing that code and you're the only one that's ever going to work on it. Great, go ahead. But otherwise, somebody's going to need to be able to understand that code. And I really appreciate the fact that the simplicity of the syntax and the way that they force you into writing maybe a little bit longer but more understandable code is I think it's absolutely fantastic. And then, you know, again, going back to like the things that matter when it comes to cost savings in a cloud environment, I think the performance of Go really makes a big difference, particularly for microservices. So these are the reasons why I think that Go is continuing to be a really good choice for Route. Of course, you know, like there are engineers who are down deep, way more in the code than I am at this point. And so I started crowdsourcing some answers here. What do other engineers at Route appreciate about using Go? Some of the answers that I got: strips out unneeded bloat from inheritance using composition. Interface struct relationships, extremely powerful. Strong backwards compatibility. This one I hadn't thought about until one of the engineers pointed that out. And I thought, oh man, I couldn't agree more. I have been in, you know, I've worked in Python, going from Python 2 to Python 3. Holy crap. Huge disaster. It's a major, major benefit to have strong backwards compatibility. Great package management and versioning with modules. You know, going back to that question, when did it come out? Version 11. It's been really strong since then. It took me a little while to get used to that when it was released. I was used to doing some really funky things to try and get even internal tooling built into my projects. But it's really cool once you get in there and get using it. No runtime dependencies, easy cross compilation, core libraries are built for application building, i.e. HTTP clients right out of the box. I think these are all really great answers. A lot of this stuff, I mean, you know, when you open up I'm going to pick on Java. When you open up a Java project, if you want to build an HTTP client, you're going to bring in 4, 5, 6 different libraries just immediately because you've got strings. That's great. So, who else? Let's go. I'm sure most of these, yeah, hopefully everybody here is raising their hand. There's a lot of companies that love Go. Obviously, it was created at Google. They use it for a lot of projects, a lot of internal projects, and a lot of very customer-facing projects. Docker is another one that's pointed out regularly as a major success story for Go. This is a system that operates just at an incredible level of compute and detail and operates in Go. Dropbox, Uber, 1Password, Kubernetes. I mean, the list goes on. I thought about including all of the Utah companies. There's just so many, right? It's amazing actually how much of a hotbed for Go this area is becoming. I think it's really, really cool. So I'm going to kind of switch gears into what other people like about Go. So I've spent a lot of time talking about Go with other engineers. I have friends at a lot of really big companies, some friends who have used Go and then moved into other languages, some who've stayed in Go. And then I also, when I started prepping for this presentation, I started talking to some more people as well. Kind of started off thinking about trying to talk to engineering leaders. Realized pretty quickly that was a mistake for a couple of reasons. A, they're all really busy. And B, like they're not the ones you should be talking to, right? It's engineers who should be making decisions about the stack, who are in it every day and working on it constantly. And so I just got to working and talking to engineers about this. So, you know, the general themes follow with what with what all of you frankly know and what you're gonna find on the internet. People love the performance of Go. People love how easy it is to learn. It's not object-oriented, and I know there's some nuance there. It's open source, and there's ease of maintenance. This is kind of the categories that I pushed a lot of different commentary into, and I'm going to talk about each one individually. So performance-wise, a lot of people start comparing Go to much lower level languages. This is a huge deal that we don't talk about very frequently. I mean, the fact that you have a language that builds in a lot of developer accelerators like garbage collection to systems that don't push that stuff in, and you still talk about its performance like you talk about those, that's a big deal. As we got further and further from those lower level languages with things like Python and Java and a few others, or a lot of others, we started getting slower because we were adding so many things, the languages that just you got right out of the box that were going to immediately affect your performance. So it's a big deal that when when most Go developers talk about the performance, they're comparing it to a totally different subset of languages than the one that really it falls into, which is, hey, we've got a lot of developer accelerators. Most of the people that I talk to believe that Go heavily performs that other subset, right? Java, Python, JavaScript. And, you know, some of them will go to, hey, like I've run, you know, specific benchmarks for the kind of workload that I'm operating under. And so I know in very specific cases that Go is more performant than these languages. And of course, there's also outliers on the other side of that. You can absolutely find certain kinds of workloads that are going to work better. But in general, the consensus is like, hey, you know, performance-wise, Go outperforms these languages. Concurrency, again, like, you know, and I talked about concurrency. This heavily factors also into the performance perception. If you make it very difficult to operate concurrently in your language, you're going to try and find ways not to do it. And so your performance is going to suffer. You know, a lot of people cited benchmarks around regex. This is a classic one in software engineering. Regex is used as a baseline for a lot of different languages and other systems. Go's is actually, and I always love that comparison because I am a big regex nerd, and I really love to see when you have a powerful implementation of regex. And then, universally, developers believe that just in general, Go is a great performer. I think this stems from the fact that, we tend to associate a lot of abstraction with lower performance in general. And you don't get a lot of that really, really high level abstraction in Go, especially not right out of the box. And so I think a lot of the things that we think about when it comes to performance are very much affected by the fact that it's lightweight. So another category here that's a really common refrain when talking to developers in Go is that it's easy to learn, particularly when you're coming from pretty much any other language. As long as you have some kind of background in how to program, getting to Go is not very difficult. The syntax is relatively simple. You are pushed away from doing things that don't look like what they are. And so it's really relatively easy to learn. And in fact, one of the interesting things about my personal experience with talking to developers in Go is that if people have been in the industry for a while, I very rarely find somebody who has only worked in Go unless they're, straight out of school and it is the first language that they worked in. That's fairly rare. Most people are coming into Go from other languages. Now, part of that has to do with the fact that Go is relatively new on the scene. But it's also a testament to the fact that there's a lot of people that think like me in the Go community where it's like, hey, I just want to use the best tool for the best job. And so I'm willing to, I'm not just going to be a Java EE developer, and that's the only thing that I'm ever going to do in my career. I'm going to be able to use the right tool. I think that's a more common thing for people working in Go than in certain other languages. Part of that also goes back to being a language that doesn't have vendor lock-in through being, my brain is completely farting, because it's open source. Another thing that's commonly mentioned, Go routines and channels. Again, I hit on this. Go routines and channels are relatively easy to understand comparatively to a lot of other systems for concurrency, and particularly languages that don't natively support concurrency, and you start getting into other ways of doing it that are not native to the system. Interfaces in Go, I mean, a few people touched on this. It's interesting. There are a few aspects of Go that it's like, okay, you can pretty immediately understand how to start using them. To figure out how they're powerful, usually it takes a little bit of time to wrap your mind around. But once you get going with them, it's like you begin to love them really quickly. I think interfaces is one example of that, where it's like, hey, a lot of people can immediately start implementing interfaces when they get into Go, but it's later down the line when they realize exactly how to do that really effectively and start to love it. Go's not inherently object-oriented. So one of the reasons why I bring this up is just it's so common. It's so common to hear this from people coming in from other languages. They dealt with a code base somewhere, some other enterprise company, big company, working in Java, particularly Java EE or Python or whatever, C++, where I think we're all very well of the pitfalls of having this big inheritance system. And everybody talks about, hey, well, you're just writing bad object-oriented code if that's where you go with it. But the fact of the matter is, you work on a big code base, you're going to have people who abuse it, no matter how good your system is. If you've got 100, 200, 300, 1,000 engineers working on a system, somebody's gonna abuse it and figure out how to get it through the code review process. It will happen. And so then definitely having worked in Python and a few others, having to run up and down the inheritance system in order to figure out what kind of cascading problems you're causing by making changes becomes a huge hurdle. It's a pain in the butt. And a lot of people talk about that fact really openly when they move to using Go. Like, oh, I'm so glad I don't have to track down somebody else's really bad code that they wrote that I had no idea I was going to affect when I made a change to some parent somewhere. You know, object-oriented is inherently a little bit more complex because you are providing layers of further and further abstraction. It's that further and further abstraction that starts to complicate making choices. For me, this was really hammered home again when I started using Django and larger platforms where I felt like decisions were being made for me. The biggest problem wasn't that there was only one way to do it with that platform. The biggest problem for me was that I had no idea how performant that thing was, and I had to test to figure it out, right? Versus other things, because I don't know what else is added to that every time I do it. And so that leads to this, you know, a lot of people are probably familiar with, I just wanted a banana, right? The creator of Erlang has this famous statement around, I wanted a banana and I wound up with a gorilla and an entire jungle. And that as his, you know, as his comparison for object-oriented programming. And, you know, I think that's very true. You get a lot of extra context that you really have no desire for or need for in a lot of cases when you get into these large OOP languages. Goes open source. You know, if you've worked with people who, like, some people really love going and working in .NET for their whole careers. There's nothing wrong with that. But there's definitely vendor lock-in that happens in a non-open source language. And so the problem that you've got is that you're locked into contracts that increase in size. You're spending more over time, and you know you get further and further away from the ideal of being able to use the right tool for the right job. Because the fact of the matter is, if you're paying for a tool, you're going to use it, right? And your company is going to be incentivized to continue to use that tool because you're paying for it, and it's very difficult to do anything else. So I've talked to a number of people who really appreciate the fact that they feel like, hey, you know, Go and similar languages, I feel like I can write in whatever I want, and Go is the thing that I choose to use, and that's a real positive. Ease of maintenance is a consistent theme, and it comes up through a number of different ways that engineers talk about ease of maintenance. Part of it has to do with readability. You know, like if something's more readable, it's going to be easier to maintain. There's no question. It's also, you know, as I previously mentioned, it's syntactically more simple, and it's fairly easy to write it pretty concisely. And by concisely, I'm not only talking about the size, but also about, you know, in the most straightforward way. It's easier, in my opinion, and a lot of other people's opinions, to write Go that just makes sense and is relatively concise. And then, you know, referring back to the previous slide, a lot of devs feel like, hey, I'm coming from a large OOP language, and, you know, I had to have a file for every single class that I've got, and I've got to format things in a specific way. And even though it might have made a lot of sense in the beginning when you've got a smaller code base, over time it gets so big and so bloated that I have to go searching for all kinds of stuff in order to figure out even where I'm going to be making changes to. And so they appreciate the fact that they can get back to more simple ways of doing things. And then this is also a common refrain that I hear when I talk to engineers using Go, is that they feel more confident jumping into a code base in Go that they don't know than they felt when they were working in a different language. Part of that has, I mean, I'll admit, and even at Route, we have some people who write Go very non-idiomatically. They came from a different environment. Particularly, we have one engineer who hasn't been in the company for a little while, but he came from a background of writing a lot of Java. And when he came in, he wrote Go like it was Java. And to be honest, he was a very senior engineer. One of my favorite engineers on earth, actually. He's super fast, very talented, but he wrote Go like it was Java, and nobody wanted to call him on it because he was just cranking out systems that nobody else was currently working on, and we just needed stuff to work. And so it was like, well, we can have the conversation about being idiomatic, but maybe now is not the right time, right? And so we added elements into our code base that definitely looked like Java. But what I will tell you is that, in my opinion, even his code that was written like Java in Go was far more understandable to people than systems that I had seen other places where people didn't really know what they were doing idiomatically and were writing non-idiomatic, for instance, Python. If you write non-idiomatic Python, you can get into some places where people really have no clue what you're doing. That's harder to do, in my opinion, in Go, and a lot of people that I've talked to feel very similarly. That's a major and powerful benefit of operating in Go if you feel like you're more empowered to jump into a code base that you don't know, in my opinion. So what's the TLDR? It's fast, it's light, it's easy to learn, has great concurrency. So, you know, just high level, those are the themes that I hear consistently over and over and over again, talking to engineers about why they like using Go. Final thoughts here. So future-wise, things are just looking so great for Go. Fact of the matter is we have a lot more companies that are using it. We have a lot more engineers who are getting acquainted with it and beginning to advocate for it, right? And we're, of course, getting more features. When I first started working in Go 6 years ago, it was a very common thing to hear, hey, you know, I would love to have a library for XYZ. There's just not a lot out there. It's a totally different ballgame from 6 years ago. There's all kinds of stuff that you can go look at, and especially with modules now, like things are just, it's headed in a direction where you no longer have to hear the refrain over and over and over and over again. Hey, like I would love to be able to just have something that does this for me. I don't trust that Go has a big enough set of libraries to do that for me. And then according to GitHub, I just pulled this a couple nights ago, actually. Based on the volume of pull requests into GitHub, currently, Go is the third most popular language in GitHub right now. Now, of course, there's the standard caveats. These are publicly accessible repos, right? But here's the thing, in my opinion, about publicly accessible repos. This is a bit of a side note. The most genius thing Adobe ever did, in my opinion, was they gave their software away practically for free to students. Because when those students went out into the world to every employer, they were advocating to go use the systems that they knew how to use, which was Adobe, because they'd been using it for free. Well, guess what? For the company, it's not free. It's very expensive, right? But they can afford it, not like those students could, right? I think the same thing is very true about what happens within software engineering, where you see people operating their personal projects and where you see people having excitement to go work in, that's going to follow. And eventually the companies will follow with it, right? We're going to build in things that people are excited to go advocate for and for us to start building in. So in my opinion, to say that like out of all of the publicly accessible repositories that Go is the third most popular, that's really exciting. And that's it. I hope I kept more of the audience this time. I appreciate you listening to me ramble for the last